Hello, hello, friends. We will be starting in a few minutes. So I'm hoping the people outside can hear me, but if you can start filtering in and getting settled in, we'll be opening in about 3 minutes.
So welcome to the first edition in this format of a
Hello, hello, one,
With a
two, three.
really
This is a mic check. Nice.
source. Keep in mind that we have a Fedora booth downstairs on the expo hall. We are behind.
Yeah, mental consistency. It'll work out.
Just let us know. We will find the person you need and arrange for time for you to ask questions. But thank you all. This is Getting Started in Open Source and Fedora. My name is A. Okay.
I'll just give everyone maybe
This is me.
30
This
to
is
60 more seconds to filter in,
matrix
settle down,
add
and then we
spots.
will kick off.
For today. For you, the roles they need. Contribute.
All right, all right, all right. Hello, friends, and welcome to day 2 of Planet Nix. Yeah. How's everyone doing so far? Have we been having fun? We learning things? We meeting new people? Yeah. I like the front row enthusiasm. Love it. So a couple just standard updates today. We will still have tracks in both rooms. We'll have talks in tracks 1 and 2, so both room 1 and 2. There have been a couple small schedule changes, so do check the online schedule. That is the one that's going to be the most up to date. Most notably, we have swapped the tectonic section with the steering session.
Reference.
And also, Ilko's Wasm talk will be getting
Experience with
moved
you.
into here
Connections with
on
people in
the main
different
track.
companies.
Yeah, no problem. It's funny, we were just joking about eventual consistency and everyone filtering in and being ready to go, and that's just how it goes sometimes when you're live. But otherwise, hopefully everyone's having a good time. We've really enjoyed hearing the conversations that are happening over in the main floor. People have been talking about the things that they've been building, how the community has grown since like the last 20 years of different either online or in events. And I think this is the third or second Planet Nix. Second, yeah. Oh, I've been to both. Cool. NixCon.
Okay,
I knew there was a
chapter.
catch.
I'm
I was like,
using
I think it's a
OpenStack
2 or a
as
3
home with
thing.
the docs or
But yeah, so we will be having the workshops in the other room. We'll have sessions here, as I mentioned. Lunch will be similar to yesterday. You will have a 90-minute break to go get lunch and then come back. You know, we'd love to have you come back. Otherwise, we will still be doing video interviews out there. It'll be me, so if you see my sparkly sequin jacket somewhere out there with camera, feel free to come say hi, talk to us about Nix. I didn't bring it up here, but you will get a special branded little Moonflake cereal box for partaking. And
lab. Most
yeah,
open source projects are in
I'm ready to introduce Ron, but that's okay. We've got a couple minutes.
rule. OpenStack for it.
We are getting a second audio feed.
We have our own system. We then mirror to GitHub, but if you're going to make contributions, it's somewhere else. Identify your interests and your skills.
Yeah, this is a new one. Do we have any AV friends in here from the AV team?
Want to work?
It's gone now. Now I feel like I'm hearing the voices inside of the room. Is that speaker?
But look for projects with good documentation. Because that will.
Yeah.
Because if there's no documentation,
I think we're getting a double track on audio. We're hearing somebody else.
Actively with the
I love this. We've got front row helping troubleshoot for all the people in the back that can't quite hear what's going on, and I'm kind of really enjoying the spirit of camaraderie over here. I know. We were joking right before we went live. We were like, there's always something that goes wrong. It's just the nature of live events and tech. Yeah, I've got to enjoy the fun, right? Keeps life fun. Keeps it interesting. Yeah, this is 101.
access type of contract.
Hey, that's me.
You don't need to know all the pieces that connect together. Be like a one repo friendly. Look for
Great, so thank you everyone for attending, and we're going to get started with the opening ceremonies with Ron. And he will be talking about a secure Nix, the State of the Union. Oh, is it We are doing it live. There's a button here, but it didn't help it, so maybe we need to wake up the projector. I think if we just front load all the troubleshooting, the rest of the day has to go smoothly, right? Oh, yeah, it's turning on. we did dim the lights already. I think we'll put your slides on and double check. And if it's not coming up, you should toggle it. There we go. No. There we go. Yay. I think this will work too. Let's see. Well, if you bring your own, if you bring it. Oh, okay. Then you're good. Okay. No worries. Almost ready. So, it was dimmer yesterday. I think you said that too, right? We can do some more dimming. How's it looking in the back? Can we see it okay? Yeah, thank you. All right. Doing it live. All right, here's Ron.
All right. Sorry for the delay. Thank you, everybody, for joining us on Planet Nix Day 2. We're kicking off another day of a lot of talks, a lot of energy. I know it's 10 a.m. and probably we all went to sleep at 8 and woke up at 6 and ran a half marathon. And I'm just giving you pretty much my friend Ben's schedule, for those that know. But anyways, thank you all for coming. To kick off, what I like to do is, anybody heard me ever talk about the types of fun? Anybody? Anybody? Like Philip, great. 2 people, Tom. So I like to consider things in life in 3 types of fun. Someone introduced me to this about 4 years ago. And the way I like to think about it is pretty much that, right? Type 1 fun is it's like fun to do, fun to remember, just fun end to end. Type 2 is kind of like, you know, it's a little hard. It's kind of like working out. It's not maybe the funnest to do, but you get that immediate rush right after. And it's also fun in general. And then type 3 is kind of getting chased by a bear. It's not fun to do. It's not necessarily fun to remember, but it makes for a great story. And honestly, that's how I think about organizing Nix-related events. I'm kidding. It's definitely type 2, but all I'm saying is that a lot of folks put in a lot of effort, and I'll call them out in 1 sec. So I want you to remember that when you're thinking about organizing a Nix event. But here's me. Here's me smiling. Here's me smiling exactly 6 months ago. This is Ron when he was naive. Thank you. This is Ron when he was naive. How many parents do we have in the crowd here today? I don't know how you do it. This is when I told the community that I'm expecting a kid, and you know there's that kid now. So it was my wife and I were expecting, and then that kid happened, and then he's 3 months old now, and he's here with us. I don't know. Kudos to you guys. Like, yeah, we're paused right now. So, anyways, lots of lack of sleep. So sorry for the lack of energy. And again, if you want to remember how I smile, that's how I look like. I'm kidding. It's good. But quick shout out, a lot of folks were involved in making this happen. I don't know if any of you are here in this room, if you can raise a hand and keep it up for just a second. Dan, just making sure you're listening, raise your hand. Anyone else? Anyone else? Wow, they're all outside. Oh, there's Rock. They're all outside still organizing Planet Nix. There's a bunch of volunteers. Justin's around here as well. I want to take a pause and just thank everybody that made Planet Nix, happen. So thank you guys. And then obviously there's last year kind of Phlox completely soloed it. this year we started opening it up to a little bit more of partnerships for organizations to also come in. So we had a nice group of a handful of folks that came in and partnered in making it happen. So thank you to them as well, and hopefully we can keep doing the Nix magic. And the next thing you can help fund is NixCon, which I think just got announced in another very exotic European location. We keep it right now at Pasadena. It is exotic, especially certain times of the day. So how many of you feel that you know how to talk about Nix with everything that's happening in the industry today? Yeah. Yeah, it's pretty, I'm going to say this only once. I'm not allowed to say this more than once because then it goes from PG to 13 to R, but it's pretty fucking hard. The way I like to think about Nix, and the reason I'm sharing it is because I think that's our role, right? That's the role of the folks here in this room, the role of the folks listening in, the role of the folks in the ecosystem. It's about how do we continue to establish a sustainable community and an ecosystem that can thrive 5, 10, 20 years, right? And way further along than any of us want to continue putting up with it. And at the end of the day, it comes down to how do we communicate? So I've been using this since pre-ChatGPT. What I added is that little thing plus a lot. The way I like to think about Nix, and I hope that's kind of helpful to framing for folks to consider when they're talking to folks, is that Nix came around 20-something years ago, and it said, there's an order n problem. And that's the complexity of software development. Why? Because every time we reach a new frontier, we're human. We like to take that new frontier and we like to find something new that's harder to do with it. And that's good. That's great. A lot of times it brings us a lot of cool things. Sometimes not so cool things, but usually I like to be optimistic about it. And software engineering is an order n problem, right? And along the history of software engineering, we've tried to solve it with different patches, with different band-aids. I think containers, for instance, right? We were just here yesterday with Kelsey Hightower. They have an amazing utilization within orchestration, within deployment. Why? Because taking a box and shipping stuff inside of it works. It's a square. We work in squares. NVIDIA works in triangles, I know. Excuse me. But for instance, there are areas where that box just doesn't work, and we ship that container on the left. So we've added all this patching to deal with that complexity in ways that we didn't have to. And before I go into, the solution, a lot of folks are asking me, does Nix still matter? Does it still matter in the age of AI? Does it still matter in the age of agents? I think recently I've heard someone on Twitter say that package managers don't matter, right? Package managers don't matter because agents are going to just be like, what do you want to write? You want to ship a new age CRM? I got you, bro. You need that library. I'm going to write it for you. It's going to be ultra secure. As much as I love our model friends, I personally will not trust them to, right now, package everything for me. But there is a lot of uncertainty. But from my perspective, this doesn't change anything about, thank you. This doesn't change anything about Nix. It just makes the problem more complex, hence the n plus a lot, which is a mathematically correct equation. It just means that the complexity has grown, right? There's, I think in 2022, GitHub came out with a state of GitHub or whatever they call it, and I think they said that there's 25 million engineers in the world today, right? That's where the complexity was, if you use that as a metric. But now, I would say that each engineer has multiple agents running. And I think in the next few years, we're going to have hundreds of millions of these engineers doing stuff. What are they doing? They're creating code, right? I don't know if everyone has looked at this article. I highly recommend checking it out. It's art. It's not science. Steve Yagi wrote an article called Gas Down. And he pretty much engineered a way to have a mayor agent run fleets and dozens of agents that are able to do software engineering, deployments, coding in YOLO mode. And he himself uses very strong language to deter people from trying it. But this is an extreme of where we're going, right? And bottom line, at the end of the day, the order end solution is Nix. Nix comes in and, simply put, because everyone in this room knows that it's a lot more complex than that, unifies the baseline architecture of a few steps of infrastructure. Now, simply put, what happens when you have one step instead of 5? What happens when you have one step instead of 6? It's just faster. It doesn't matter what's happening on the top. It just means that whatever that solution ends up being, that solution is able to be more reproducible, more secure, more deterministic, and in general, fast. So from my perspective, this is what I tell people. Nix is the foundation on which we should be building this next layer of the SDLC. Because we now have an opportunity, and I took this, we met up with Jensen 2.5 weeks ago. And he said, you guys are all lucky. And I was like, you know, that's probably, I would probably consider that differently. But he said, you guys are all lucky because you are able to be at a time where you can redefine and rebuild flows that were static for decades, right? Everything is now kind of, the walls are breaking apart, and you can now define how the next new age things should work. And I think we have a huge opportunity as an ecosystem. We have a huge opportunity to establish Nix as a critical function in the new SDLC. It's not the agentic SDLC, it's just where the software development lifecycle is going. And the last thing I'll say on this topic, anybody recognize this equation? It's a math test. We're all about math. That guy. Good. You know what I'll say it because we're being recorded. Amdahl's law is a pretty basic mathematical equation that just says that, you know, if we simplify it, the fastest we can go is the slowest part in a multi-step process. Now everyone out there is shouting how quickly we can generate code and how amazing that code can be generated, shipped, deployed, produced. Oh my God, that's incredible. But what about the infrastructure? And I think that's where Nix comes in, and I think that's how we can think about it. I think that's how we can talk about it, right? And we're seeing it. We're seeing it happen because we're not the only people in the room that are moving to establish more on Nix, right? I mean, we're seeing it around this conference. Like, this conference is growing. There's more folks coming in from enterprises that have never heard of Nix before, but they're seeing that there's a problem, and right now, Nix is one of the only solutions that can solve it. So, obviously, a little bit about Nix and the numbers. We're growing across the band, which is exciting. It's great. But it also means that we're paying more. So I don't know if folks were interested, but we're currently averaging 281 additional gigabytes in our S3 per day. Per day. Infra team is going to talk about that. And they're going to have some call to actions. And there's things that we can do, because at the end of the day, again, going back to that sustainability, we need to think about how this actually continues to grow and flourish. And after all my other friends across the steering committee and the different teams talk, I'll have some quick points on it. If folks are wondering how much price has grown, we're almost hitting 20K. Good stuff. And one of the last things I'll say on these parts before I hit the teams is, I always think about it this way, right? If anyone's concerned here, if anyone's thinking about their jobs, what software engineering means, right? Kelsey and I were talking about it yesterday. He was mentioning that he went through 6 title changes across his career. Things will change, and that is okay. What won't, at least for me, and if it does, then I think I wouldn't be interested to be part of this anymore. I'm saying this very strongly, is contributors and community always come first. And I think that's one of the most important aspects of open source, and that's something that's human to me that I hope that we can continue and we can continue to build up, no matter what changes outside and what we can use. Now, with that said, I think that we have to work on AI workflows. We have to see how we're utilizing AI, we're utilizing agents to improve the things that we're doing inside this ecosystem. Because again, community comes first, but we have to also move forward with the rest of the industry. And My only ask here is share. If you have a flow that's working, if you're using something that's AI assisted, agentic assisted, that is genuinely not garbage. People want to know. And we won't judge you as long as you're upfront and you set expectations clearly. The one thing that I hate the most, and I make this super clear also inside of Phlox in terms of culture and how I operate, is if someone sends me something AI generated and doesn't tell me it's AI generated. I'm totally fine with seeing something AI generated because I think it's okay. You can write an email. You can even send me a meeting summary. Let me know it's AI generated and that you've reviewed it. Because the one thing I hate is if I read something and I'm halfway through and I'm like, oh shit, is this AI generated? And I just spent 30 human minutes reading something that no human has even checked before without my consent, right? When I'm talking to an agent, I know I'm effectively doing that with myself. So that's a little bit of my thoughts on where we are. And like I said, 4 hours of sleep, newborns, you parents are great. I don't know how you do it. Anyone who's decided to have more than one child, we'll need to talk after. Oh, okay. All right, a little about the teams, what's going on. So NixOS Foundation, 2025, a lot happened. I don't know if you know all the friendly faces. I am the solo representative right now at the conference from the foundation. I haven't introduced myself at the beginning, but I'm Ron. I'm one of the founders of Phlox, and I'm the president of the NixOS Foundation. And obviously now I wear an additional hat as an employee of a 3-month-old called Dove. Yeah, literally. I mean, he decides when I eat, when whatever. But we have Laszlo, we have Sylvan, we have Sebastian, we have Ryan. They're amazing people. They're volunteering. They're not getting paid for this stuff. And they really care, really, really, really care. And for those that are wondering what's been happening in the foundation, a lot. So 2025 was kind of the first year that we fully transitioned into this new foundation model. If folks are not familiar with it, there's a steering committee that is going to come up in a second and talk. The steering committee has a function in the ecosystem. It's voted in. There's a vote that happens every single period. New folks come in. They're representative of you. They're representative of our contributors. They're representative of the people that vote. And then they have they're very much empowered to make decisions, move things forward, allocate funds. There's a lot of things that happen. And there's also the foundation that is kind of in charge of keeping the lights on, and I have a little slide of what that means. But we've been really focused on that transition. We've been really focused on extending partnerships. I think we have a good few brewing as well that I would be excited to talk about. And again, there's a list of stuff, but you can reach out to anyone. There's no bar, there's no ambiguity or uncertainty. If you're not sure about something that you need, reach out to any of the faces that you see up here today. They'll try to help you out. They'll try to connect you with the right person. We like to keep finances very, very transparent. That's what we do. We started this a few years ago. Everyone here will have access to the slides, and you'll be able to see. Currently, the foundation still does not receive enough funds to be able to do what I think is the sustainable, I would say, P&L. I want the foundation to be in a position that we can fund and continue the infrastructure and keeping the lights on for at least 2 to 3 years without relying on anyone, right? That's what we need to be able to do. Right now, we're not anywhere close to that. We have partners over at AWS who are helping us fund the S3. We have partners over at Fastly. We have partners in a lot of different places that are helping us kind of fund these efforts. And I don't have the full partner list, but there's more partners on the website. You can check them out, and also we're super appreciative of them. But right now we've been able to keep the funds somewhat stable with continued funding. But this is a big deal, and yeah, I was supposed to disclose that this is not yet finalized. The finalized report will come out on the discourse. Like I said, there's continued partnerships efforts that are happening. So if you're out there, if you're in companies that have ways to contribute, it doesn't have to be cash. It can be, I think Ampere sent a machine out to Nix events. Why not, right? Testing it out, showcasing functionality. That's always good. That's always ways to engage with the ecosystem. Nova Custom came in and got involved. Who else? We got Deep Computing, Open WRT. But bottom line is, happy to brainstorm ways to contribute to the ecosystem, whichever way it could be. So if you have one, shoot it at us. We'll happy to talk to them. and provide some incentives. One other thing that launched that's really important to be familiar with, the Nix sponsorship tiers. So this is a further way to construct and structure out the way that we work with organizations. So today, you can go to the website. If you want to become just a NixOS Foundation and a Nix ecosystem sponsor, there's tiers. For each tier, you get some stuff. We try to just structure it a bit more so organizations can actually come in and get involved with the ecosystem and help fund different efforts. But like I said, there's a lot of ways to get involved. Last on this point is that there is a constitution that was written out that pretty much defined this entire governance structure. Folks that are interested, check it out. It clearly and very articulatively defines kind of the steering committee and the foundation and the work between us and how we operate and how we work. I will say that last time I was on this stage, 6 months ago at NixCon, I talked about a grant program. And we're very close to shipping it out in draft mode to the community to go look at it. Pretty much the entire idea is a more structured way for people with money to find ways to fund the things for the people who want to go work on them. Very simple model. But we just ran this with the SC, and there was a question that came up with the Constitution because there was a module there that in the Constitution, the SC needed to be part of, and we're like, yep, let's go make sure that that works out. So we're really taking that Constitution seriously. And with that said, who's the Nix steering committee tribute? Looks like Julian is looking around. Julian's slowly making his way up. Sweet. All righty. So we're going to go in and talk to our awesome community members for a few minutes, and stage is all yours.
Hi, guys.
Hey.
Hello.
Is John here? John Erickson. Paging John Erickson. No, he's not here. All right. So the two new people here, it's myself, Philip Taryn, and Julian Malka.
Yeah, Julian.
We successfully campaigned for, would you like to have more transparency and accountability? We have done some of that, not all of it. Apologies for the things undone. And we're excited about the future of Nix, as always. And
Maybe we can, maybe we can say a word of what the steering committee is and what's the general idea of this governance body. The idea is to set the direction of where we want to go with the community, both like in terms of governance and some technical aspect. And the way to do it is to try to empower different set of people, the teams, to do their job and to unblock them and to make it as smooth as possible for the people that do the actual work to do their work.
to that end, you've seen an announcement that there's a team that's bootstrapping a community team that is the, I suppose, new name for moderation. And we're excited to help them do their work, but they're in charge of figuring out the terms and conditions, if you will, for like what it means to run the Nix community spaces. Hi, there's John Erickson.
Hello. Glad to have just made it. You are in the middle of describing the Bootstrap moderation team?
Yeah. So the Bootstrap moderation team expects some more posts about from us or from them on the matter, but that's not out as of right now, but soon. Anything else that you'd like to? So are we? Yeah, go for it.
Yeah, we have obviously a lot of like topics and things that we go over, but are there any topics that we are not aware of? Are there any conversations that we are not having that we should be having? So if you have either ideas or proposals or things that are ambitious that you don't know if they are being discussed or you think they should be discussed, bring it to us.
Yeah.
So yeah, please talk to anyone or send it to us or figure it out how to get it to us, and that will be helpful. Thank you.
There's a, actually on the previous slide, so there's a meeting notes in a public Git repository one of the ways to contact us is just open an issue in that repository. If you'd like to, engage a discussion in public, like no one's taken advantage of this yet, but it's totally available. And if you, we don't have a reliable cadence of posting on Discourse, but we do have a fairly reliable cadence of updating the meeting notes on this public GitHub repo, NixOS/steering committee. So the steering committee exists per the Constitution, as Ron was pointing out, as to act as an arbiter of decisions that didn't have a central authority before. So there's been a few controversial decisions, for instance, about like the job postings from various companies on Discourse, on specific, somewhat controversial packages to at least some people in Nix packages, whether or not the teams, whether or not Nix packages has a team that's in charge of Nix packages itself. The answer is it does. Nix packages core, it's working great. For instance, most recently, where should we have NixCon? And we decided it's going to be in Krakow, which is an ancient free city. So it's going to be great. Anyone else want to?
No, not
I don't think there's another slide. Conflict mediation, governance, assisting with fundraising. We're basically everyone who's in the steering committee also wears other hats, and we don't wear our steering committee hat most of the time. It's I'm just a normal contributor on Nix packages and get the red X just like you do. Anything else, guys? Yeah, contact us. We actually love to be contacted, despite perhaps external experiences.
Infra. All right. By the way, there is a steering committee / foundation in the singular form, aka me panel. It did move, so we can shake some things around. So that's going to be at 2:30, not 1:30. Keep that in mind. Prepare some hard questions. The steering committee said that they want them. All right. Infra team. Welcome, Jonas. I don't know if you guys know this guy.
Hey everyone. Yeah, so the Infra team is probably one of the oldest team in the Nix ecosystem. And the main job of the Infra team is to keep Hydra running. Hydra is the CI that is customly built for Nix, and that builds all of Nix packages, and that produces a lot of derivation outputs that are getting pushed to the S3 cache. And yeah, like shout out especially to Hexa and VQNAT, who are the ones that are kind of on the Hydra and keeping things running. And then we have also sub-teams. For example, JFly helps a lot with some of the non-critical things, like we have a ticketing system, email system. Sorry? Mail server, yeah, thank you. And yeah, so in the last 6 months, we started, we are replacing the Hydra queue runner, so that's the CI can scale. And we also had to mitigate some bot abuse with Anubis. And yeah, it's just doing some like good job. And the other exciting things that happened is we did our first ever garbage collection of the binary cache in January.
For those of you not familiar with this, this is like a huge deal. Right? Someone should do a rabbit hole of like the Nix, expression of like all the connection between the different threads on this.
Yeah, it took a long time. We had to backfill the whole history of, like, read back all of the cache. And we were able to remove 100 terabytes of just ISO images that nobody is really using. So yeah, So shout out to Brian McGee, who did like all of the indexing and research around that. And yeah, that's it. If you want to help out, we're like available. We always need more help. And you can just reach out to the GitHub NixOS/infra repo, create an issue, or come to the Matrix channel. All right, thank you.
For those of you, Tristan, while you come up, not familiar, Jonas is one of the OG folks that when we were like, you know what we want to do about, I don't know, was it 4 or 5 years ago now? We want to go like bootstrap foundation stuff. Jonas was like, yeah. I don't know why he agreed to that. So for those of you that are not familiar, Jonas was kind of part of the initial bootstrap team that put a lot of thought into what ended up becoming it today. So thank you. Thanks, Jonas.
Hi, I'm Tristan Ross. I am one of the members of the hardware team, which I believe we started up around mid last year. So Mick92, Rabbit, myself started the team. Then we got on 048, or yeah, that name. We got Magic. Then we got Magic RP brought on a few months ago, and then just yesterday we got I believe his Pinbox is their username. They got added to the team, and our focus is hardware. If you kind of can guess, hardware is you need it because you need to run NixOS on something. So that's kind of our job. It is to coordinate between companies and individuals who want to use systems, and we make sure they work with NixOS. And so a few things has happened, like framework. They've been working with us to be able to get NixOS working perfectly on their systems, or enough that it's pretty good support. We got Deep Computing. So they are a RISC-V vendor, and we've been working on porting NixOS over to their hardware, and hopefully we'll be getting new hardware soon. And then OpenWRT has also shipped devices, and we've also been working on NixOS Factor, which allows for better configuration of your systems, and it makes things a little bit more modular with what devices you have on board on your system. And we've also been working on getting NixOS support for the 5-tab Duo, and we're increasing RISC-V, or we're investigating RISC-V support, and hopefully we'll be getting that around. Later today, there is a talk that Union and I, who's the CEO of Deep Computing, will be giving to talk about RISC-V. So if anyone's interested, that'll be at around 2 o'clock, I believe it is. Yep, so 2:30, I believe, yeah, that room, and RISC-V.
Cool stuff. All right. John, you want to come up here again for funsies? And Jay Fly, you're right after, so make your way up.
Sure. Yes, one of my other hats, as Philip mentioned, is being on the Nix team. Similar to last time, we continue to grow the team. Love Segfault and Red Vendi are new members. That's why they have the little star icon. And there's much development work remains, like new features and stuff, but I think it's especially nice to highlight some of our housekeeping and sort of how we work stuff. So we have release automation recently. That was Sergey, the first guy. I'm not going to try to pronounce that name, that nickname. And Yerk, Mick92, did release automation. So now we can have more frequent and easy releases. Sanitizers, just taking advantage of what Clang and GCC already give us to detect more bugs. We've done a huge push on performance shortly after last NixCon. I think our all-time performance improvement increase, Sergey was able to reduce the memory from 30% going into Nix 232. That was fantastic. And then a bunch of network relating overhauls too. Love Segfault did a huge rewrite of the S3 store, making it no longer use the dubious AWS SDK and use curl more, and also just improving how we did things with curl in general. So those are all things that are completely done and out today in release Next. And then coming up soon, the new installer based on the DetSys Nix installer, that is in beta thanks to Mick92's hard work, and that should be rolled out as a default very shortly. Better unified content addressing and dynamic derivations for me, that continues along. Actually, I may go a little off topic. The next work on there will be in Hydra, but also some new things in Nix too, supporting that. Concurrent and asynchronous eval, similar to the peer eval you may have heard about from Sergey. More progress on lazy paths in particular in our journey there to stable flakes, which I'm sure you all want. And then finally, we've sort of in the bits and pieces done some refactors that are getting us closer for Windows support. And FreeBSD sandboxing. FreeBSD sandboxing I hope will be merged later today, and for Windows support I can at least say that recently on an unmerged branch the Hello World derivation for Windows was finally built. Okay, yeah, very exciting. That's it from me and the Nix team. Thanks so much.
All right. I'm getting the get off the stage soon thing. So JFly, you want to come do like Tom?
Sweet. I'm Jeremy. You'll see me as JFly on GitHub. I'm the leader of the formatting team. We've got a Haskell code base. It formats all the code in Nix packages and maybe in your Nix project as well. If you're interested in Haskell or anything, check it out. Yep, big shout out to that. We have Nix packages fully formatted. It's awesome. Yep. And then, yeah, we're kind of in maintenance mode here. We're fixing bugs, adding features. You know, we're doing some stuff with experimental stuff like the pipe operators. We've got one new teammate, Diego. He's kind of the only person on the team who actively writes Haskell. I don't know Haskell, so you know I'm learning it slowly. But that's it. Thanks for using it. You can find me on GitHub.
Thank you for keeping it short and tight. You are also with a newborn, so thank you for making it out here. All right, marketing team. Lightspeed Dan.
Hi, I'm Daniel. I'm lead of the marketing team and also work on primarily branding. Unfortunately, the rest of the team couldn't be here, but the rest of them are Tilo, Flyflow or Florian, and our latest member, I didn't put sparkles on their face, but Significent or Sigma has started helping us out with some new graphic design work, which I'm really excited about. But if you're not familiar with our team, we have a few primary roles, which is maintaining the website, organizing the socials, recently developing branding and graphics for the whole ecosystem, and also surveys, which we are in the middle of processing last year's, hopefully coming out in the month or so. So we have some things that we're working on right now that we're really excited about. Tilo has been working tirelessly to make improvements to the website. I don't know if it's linked anywhere, but if you go to nixos.org/y-nix, there's a new page that we've been working on to help bring people into the Nix ecosystem, explain it to them a little more cleanly what Nix is about. I don't know if you had trouble when you first came in, but you hit the NixOS landing page and you're like, what's Nix? Tell me about it. And it doesn't really kind of get you there really quickly. It's only through like digging through it a bit, maybe looking through the docs, looking through the blogs, and you're like, oh, okay, I get it now. And we're really hoping to fix that up. And also fix a bunch of accessibility issues that have been just lingering around for a while. Like I mentioned, we are in the middle of processing the survey. I will tell you right now that we had a 50% increase in the number of respondents over last year. And if you've ever seen like the kind of growth curve and like the number of contributors, that is definitely real. The whole distribution of contributors has shifted hard into like the less than 1 year, less than 2 year. So we're getting a huge influx of people coming in, which is really exciting. Let's see. For socials, actually, I was talking to the team, and if you have a meetup, an event, or a cool project that you think people should know about, hit us up. Let us know. Give us a little copy, like a little blurb to say, and we'll throw it in our socials. We want people to know about these things. We want people to like have a centralized place to like get their news. So if we can start funneling these things in, hopefully the word will spread, more uniformly, rather than just being like, oh, I stumbled upon this, or I heard about it a year afterwards through a friend. So let's see what else. And right, Sigma. Really excited what they've done. If any of you got to go to FOSDEM, saw there was a Nix booth, Sigma had created this really amazing banner design in like a few days. I'm really excited for the work that they're spooling up on right now. Look forward to the next release. I'm really hoping, no promises yet, but I'm hoping that we're going to start having desktop wallpapers as part of the release. I'm really excited about this idea that, you get the new release, you put it on your laptop, and you go to a coffee shop or a hack event, and people are like, "What's that?" I'm really trying to find ways that we can bring more attention to ourselves. And I think the final note is, if any of this interests you, let us know. There's only 4 of us, and we have more than this amount of work to do. There's many other things we would love to do, like spinning up more blog posts, newsletters. I might need someone to take over doing surveys. So if you're interested in like helping spread the word or have any kind of like artistic, inclinations, drop us a line in Matrix chat. Yeah, thank you.
All right, and I'm going to call up Connor. Before that, there's a security team. They're not here today, but Hexa and the crew over there are doing a lot of amazing work. These are one of the areas that as an ecosystem, we definitely need to be investing more into as more companies, individuals are looking to Nix to become that foundational lower platform for what they're building. So definitely check it out. Talk to them. If you have some background there or interest, reach out, take part. And with that, Connor. Single-handed, no, I'm kidding. Connor is a big, huge part of making CUDA happen on Nix, so thank you.
No, you were right not to clap. But yeah, so I'm on the CUDA team. There's 4 members now. I'd like to thank Gaetan and Yuri, our newest members, for joining and helping out. No one other than me was able to make it here today. They're all largely abroad, that is to say not in the United States. But the goal of the CUDA team has always been singular, and that is making Nix and NixOS the first choice for users of CUDA accelerated software. So that is a very broad, very difficult goal. It is challenging, so I do invite you all to get involved, and I'm going to talk a little bit about how in a moment. But first, let's talk about what we've done so far. Since we last presented in October at NixCon, we've landed a giant rewrite of all of the CUDA packaging inside of Nix packages. All of the package sets are now constructed almost directly from NVIDIA's manifest that they publish. That's going to be huge for increasing the rate at which we can get updates out, as well as making maintenance easier. It doesn't solve all of our problems, but it is a good first step. NixOS 25.11 was released. It supports CUDA 12.6 through 13. And on master, we additionally support 13.1. And that was one of the first CUDA releases that I myself didn't have to author. One of our newest members, Gaetan, was responsible for doing that and pushing that across the finish line. So thank you, Gaetan. In terms of general stuff about the team, we have a new website, nixos-cuda.org. Thank you to Jonas and Numtide for hosting that for us. We've also got a GitHub org of the same name, NixOS CUDA. One of the new repositories that we have is one called CUDA Legacy. This maintains all of the different CUDA package sets that have since aged out of Nix packages. CUDA integrates fairly tightly with GCC and Clang, and so when old versions of GCC and or Clang are removed from Nix packages, so too go the Nix packages CUDA package set. So you can find all of those older toolchains and versions of CUDA vendored and supported there. It is on best effort because it is quite tricky to keep that stuff building with the newest things, but if you need to use an older release for a little bit longer, CUDA Legacy should be the first place that you go. In terms of infrastructure, we have our own Hydra now. We are building, caching, and for select packages, even running GPU-enabled tests. And that's fantastic. We didn't have that before. And if you've used CUDA, you are familiar with runtime failures. The goal is to spot those earlier. Coming soon, we're always working on better documentation. That is a perennial task. If you're using CUDA and you get confused or you don't know what to do, come join us in our Matrix chat room. We're there to help. Let us know where you're stuck or what you're having issues with, because that's failings on our part in terms of documentation or tutorials. We've been working on a metadata layer to better track all of the different constraints and dependencies that NVIDIA's packages have, both between themselves and with other packages like PyTorch. And most recently, thank you, Sylvan, for pushing the problems RFC implementation across the line. We're excited that we'll be able to offer better evaluation errors via the problems implementation. So if you try to build for a known not working configuration, instead of obscure error messages telling you to allow unsupported systems, you're going to see why we're trying to stop you. In terms of things coming forward on the nixoscuda.org page and the repositories associated with that, GCC 12 is not looking too good upstream and or has already been removed, so that's going to find its home in CUDA Legacy. And we're working on our Hydra to allow rolling stable and release channels, as well as doing more GPU testing. So in terms of involvement, if you have a CUDA-enabled package that you use or you enjoy using, try writing some tests for it. A lot of the functionality that CUDA enables is all runtime, and that's very hard to test. So feel free, jump in. We're working on documentation that says here's how to get started writing those tests, but we sure could use the help.
And again, huge hands to Connor here, because I do not know where we would be without this team. I will say really quickly, so we're gonna start wrapping up real quick here, and we're gonna have some give us 2 more minutes. There's actually a few things that I hope we'll be able to announce in the coming weeks around CUDA, around partnerships in that domain. And honestly, the only thing I want to say is that if you're a part of a firm or care about CUDA and about this ecosystem, reach out to us, reach out to CUDA, reach out to me. I'll get you involved, whether it's as a company that wants to fund these efforts or as an individual that wants to take part in them. Really, really important stuff. This goes into the what we can do category. There's a lot we can do. We've been doing a lot as an ecosystem. You have been doing a lot. The contributors have been doing a lot. Keep that up. And I think we're going to have another amazing 2026. And I'm very, very excited to meet you guys over at NixCon. And the last throwback is this is what the first NixCon looked like right after COVID. It was about 140 people in a windowless Parisian basement. So we are only getting better from here. So thank you guys. Thank you for being here. And we'll stop with this one, and I'll introduce the next speaker in a second. All right. Sweet. So one of our partners, I want to welcome Anish from Anthropic over to the stage. He's going to be launching the new version of Cloud right here. That's what I heard. Is that NixCon 27? Is that when we become important?
I don't know. Hey everyone, I'm Anish. I work at Anthropic. First of all, thank you for the organizers, the community for making Planet Nix happen. This is our 3rd year here, and we're really glad to be sponsoring this year. So thank you all very much. If you don't know us, Anthropic is an AI safety research lab, and we make Claude. So if you've heard of Claude Code, that's us. And that really means 2 things being an AI. One is we're moving at hyperspeed. Everything is moving at the speed of light. And the other thing is we're always at the frontier. We're always doing things that haven't been done before. And, occasionally breaking our systems and our vendor systems along the way. And that means a lot of imagining from first principles because it's things that haven't been done before. There's no playbook. And so that's one of the big reasons that we've made a big bet on Nix to kind of build and deploy all these systems so we can have all that control, that precision, and that reproducibility. We're also been really pleased to be able to be contributing upstream, not just little bug fixes, but larger features as well. So we just landed a rewrite of the S3 substituter in upstream Nix. It's way faster, and it's also a lot more reliable. And we got enough contributions that Bernardo actually joined the Nix core team this year. You might have seen on the slide, so we're really happy about that. In addition to upstream, we're also working with some of the other, great organizations in the Nix space on other improvements. So things like faster evals or better and more ergonomic packaging. Sam gave 2 killer talks yesterday. Bernardo talked about Nix for remote builds and what's missing and how we add that. And Sam just gave the funniest deep dive story about how we rewrote like our whole development environment just to make Nix builds work when sandboxing. If you didn't catch them yesterday, definitely watch the recordings. They were absolutely killer talks. And I will say, if you found those interesting, or if you just want to come talk to us, we've got a whole 9 of us here at the conference this year. So come by the booth. We'll be around. We have a lot of weird problems with Nix, so we'd love for you to come help us figure out how to get out of these weird corners that we've found ourselves in. So again, thanks everybody. Really glad to be here, and here's to a great Planet Nix.
Thank you, Anish. All right, last 1 minute from Jonas. Thank you, and then I'm fine. We're off the stage.
Yeah, we'll keep it short. Hi, I'm Jonas. I'm the founder of Numptides. We're a consulting company. We like to build things. We're kind of all senior engineers. So if you have a startup or a bigger company, we can come in and help you maybe offload some of the things you don't want to focus on. Yeah, and when we're not working, we like to build things, so we contribute a lot to the Nix ecosystem. If you use the Flake utils or System Manager or things like that, that's us. And yeah, we love to build things, so excited to do more of that in the future. And last thing is we're running a hackathon. So if you want to hack on something with Nix, build something around self-hosting, you have the whole day, and at 4 p.m. at the ON conference, you come, we do demos, and there's prizes. We have RAM as a prize. All right, that's it.
Thank you, Jonas. All right, I'm getting off the stage. Thank you, guys. Have a great second day, and we'll see you all soon.
All right, I know we ran into the break a little bit, so we will start the next talk at 11:05 so that you have time to go to the bathroom, get water, do what you need, and we will see you right back here, 11:05. Thanks, friends. All right, all right, all right. Hello, friends. If you can make your way to your seats, get settled in. We will be starting the next session in less than 1 minute. All right, thank you and welcome back to day 2. It's been a fun and eventful morning, and we are excited to continue going with the sessions. So, if you could help me to give a warm welcome to Craig, he will be giving your next session.
Hello, hello. Testing, loud, quiet. Okay. So hello, my name is Craig Jackson, and thanks for joining me. I've been watching NixOS as an observer for a while now, and over the last couple of years, there has been a lot of movement in the CI, CD, and build spaces of NixOS, Nix Anywhere, dev environments, even micro VMs. And then AI happened. And with AI, I really think that all of the inherent barriers that kept NixOS from being used and was a nervous choice in the past, I think it's finally eroded away. And the time is now to start using Nix. And it's gaining ground out on the network edge where I work in monitoring, alerting, build runners, and infrastructure testing scripts. But first, the obligatory who am I? Well, my name is Craig, and I'm a redneck adventurer when I'm not working, climbing mountains in these off-road machines. I'm a synthesizer enthusiast. I like turn buttons and turn knobs and push buttons. But process and automation has always been a part of my life. I studied horticulture in college, where you automate the life of a plant. I worked in healthcare as an orthopedic surgical consultant, where I worked with surgeons and hospital systems to increase efficiency and minimize waste. COVID let me leave that industry, and I'm happy to return home to the internet because I found IRC in my teens, and I've never left, and the internet is home. So I finally came back to IT, and now I'm a DevOps engineer at a company called NetActuate, and we are a global infrastructure cloud provider with a network-first focus. So we have a managed Anycast network that our customers use for low latency connectivity to their end user. We even hold the HRoot DNS server on our network, as the low latency connectivity in Anycast is kind of our bread and butter. And so what we're going to talk about today is the importance of the edge network, how significant it can be in both cost and management requirements, the difficulties in setting up that infrastructure, and then we're going to explore how NixOS adoption is being increased out there on the edge in these single-use cattle-type machines. And we're going to end it with trusting in NixOS, but I'm at a NixOS conference, and the talks yesterday and today are more about how to give the messaging to other people and recruit other people to our cause. And so I'm going to modify the trust at the end a little bit, because I believe that Ron and Kelsey had the message correct yesterday. But to get back to the network edge, I'm going to use a few terms, one of which being POP. I'm going to say that a lot. That's just a point of presence where we announce your service across the globe to bring your end user into it. But the network edge are multiple POPs kind of loosely fabriced together to create multiple entry points into your service around the globe. It's important to maintain an edge network and to build it for multiple reasons. The closer you can keep the assets to the customer, the less bandwidth charges you'll incur over time. As you increase regions and your service grows, you can rapidly scale with a new POP. And it can also give you data sovereignty compliance. That's becoming very important as the geopolitical system falls apart. And so more and more countries and more regions want you to keep their civilians and their citizens' data in the country that they live in. And ultimately, when you do have a resilient and reliable edge network, your customers and you enjoy low latency connectivity. And so what type of infrastructure and what type of workloads makes up an edge network? Well, again, we're bringing people into your network and into your service. And these machines are typically single-use machines, And so they're quite perfect for Nix, in my opinion. Such roles would be like a BGP ingress daemon or a reverse proxy into a Kubernetes cluster, firewalls, load balancers, etc., depending on the service that you're providing and the needs of that service at the edge. And there's a whole lot of different ways to instill this infrastructure on the edge. We have all the infrastructure as code tools. We need to manage multiple data centers, so there's infrastructure management tools. There's networking appliances that we need to connect together in all of those different locations. And all of that's loosely tied together with Git runners and webhooks and everything else. And once you have that infrastructure, we need to alert, we need to monitor, and we need to observe. So there's a whole lot of infrastructure that surrounds your service on the edge. All of it's important, and all of it can be dangerous to maintain over time. And so these challenges present itself in multiple ways. And the Nix answer that we already know is really the configuration drift. We need to be able to trust what we're doing, and we need to be able to rely on it consistently over time. And on the edge, since you're not in control of the data centers, the locations, and you're not in control of the hardware and who's going to be working on it, it's just timely to maintain, it's expensive to maintain, and when these systems start to fail, you can no longer trust the infrastructure on the edge of your network. And all of this leads to increased costs over time, not only in managing the infrastructure itself, but the configuration spread out over 2 or 3 different systems. You've got Terraform and Ansible, and when you're using multiple points of presence, you really would benefit from having Netbox and AWX. So now we've just increased our amount of infrastructure that we need. There's also time spent managing all of those. And since it is scattered and we have all of these little pieces of data that's all over the place, who's forgotten to update the CI/CD vars and pushed run? Who didn't notice the GitHub runner didn't finish yesterday? We run into those problems. And the eureka moment with Nix came for me when we enabled the ability on our platform for customers to install Ubuntu. They can go in and customize it. They can edit their SSH keys. They can add their ingress rules. They can give the basic bootstrapping already set up in the machine. And then they can lock that machine down and clone it and deploy it in multiple regions already bootstrapped. And they loved it. They instantly started creating multiple packages, one for each region. And now we have so many private images, one for each region, one for each service. It's rapidly getting out of hand because we have 45 POPs. And if you maintain an image in every single POP, well, now we're looking at 207 gigabytes of storage just for your bootstrapping images. And so these managing the infrastructure on the edge gets costly, and it gets very hard to keep the configuration in a constant state. And so Nix was brought to me by a customer, and she was trying to figure out if she could run services that were single role systems with lengthy policy-based configurations. So caching systems, BGP ingress, firewall rules. You have to put them in order and they all relate to each other. And if you mess up that rule set, the system's broken and it doesn't work anymore. And so it's easy to roll back, it's quick to rebuild, and she wanted Nix out on the edge. So I confidently and arrogantly said, it's just Linux, of course I can get it to work on our system. And she said, great. And she sent me this. Well, I don't think KVM can deploy a flake. I didn't know what to do with it, and this is why I didn't use it. This is why I didn't use it for years, because I can do it quicker with Ubuntu at this point. I have to learn this first. And so this is where I'm going to pivot a little bit and talk more about what Kelsey and Ron have been talking about. I trust in Nix now because I understand this enough to get it started. And I'm also not a tinkerer. I'm not one of you guys. I use it strategically like a scalpel to fix one singular little problem. I use that compute outside of my Kubernetes cluster. And so I don't think that trust sells to other people well, because they trust this. They trust this. And when I tell them that I don't trust this, they say, skill issue. I trust that. My Terraform works. Why do I need to learn a whole new system? Well, because this, as to Kelsey's argument yesterday, isn't consistent. It's non-converging. I have to go to 17 different systems to understand this. But what works for me is I can now begin to converge my configuration down to a base flake. And the next customer that showed me how to use it effectively in a team opened up my world, and now we're using Nix internally. I'm no longer just watching customers use Nix. I gave this talk internally last week to our company so that I can practice and get their thoughts. The tech lead, so my role in the company is I get to prototype with our architect. And then when he's done building what I helped design, I then brute force what he built and try to promote that to the customers. Here's what we just made, and here's the cool shit you get to do with it. After I gave this talk, for the first time he said, do you think I can get our Kubernetes worker nodes for our managed Kubernetes service on Nix? And I said, do you think I can? Yeah, oh, do you think? And he said, well, I need consistent boot times now. We need a predictable deployment strategy, and we need a quick deployment for Kubernetes worker nodes. It's currently slow. And so now that it's consistent and it's quick to boot and it's faster than Ubuntu once it's programmed, he's in. I've got his buy-in, not because I trust it. He doesn't trust me. It's consistent. And it's when you have everything built in. And by the way, the only reason that he's going to use this is because I've built the configuration. He just needs to load his service into it. I built the flake, so I've given him the dev shell that he needs to interact with the service that he's going to put on my infrastructure. And network.nix, this is ephemeral. We inject cloud init secrets into the machine, but we're not going to rewrite our ISO vendor data attachment because it works for every single of our other operating systems. And so Nix doesn't persist the network. That's the one caveat. But that's fine because you're going to rebuild it with your own system anyway. You can persist the network, and we automate that with a cloud init script. So inside cloud init, you customize your base flake, and then you can download the role that that flake needs to inherit. We've now reduced entirely how many images we need. We need one. And we can download the ephemeral role and reboot it into that role anytime we need to. And so now we have a seamless build process, and we've got that comfort and trust. We can treat this like cattle or pets because it's truly reproducible, it's truly declarative, and it's truly software. And so if we look back at this role listing again, the first customer brought it to me with BGP and proxies. But that configuration is a pet, in my opinion, because we're going to continue to iterate on it. We're going to roll back, and we're going to nurture those. The top 5 or 6 all kind of feel like pets. The configuration is very similar. And so if it works for BGP, if it works for proxies, it's also going to work for all of these others. And so again, the cattle, I think we can replace GitHub runners. That's how I'm using it internally now. I am getting rid of GitHub runners entirely. They're going to charge me for my own time that I'm going to run my own runner? No. Also, they're going to give me shitty implementations of their runners for me to interact with. They lock, they freeze, I have to go in tomorrow and make sure they finished. I can do better with NixOS, and I can do it better with just webhooks out of GitHub Because they let you attach a secret to it. So now I have a listener of webhooks, and the secret is the role that I want to boot. And I just have a whole bunch. I'm an infrastructure cloud guy, and I hit every hammer or every nail with a VM. So I have a whole bunch of NixOS machines turned off, just waiting. And I have a listener that receives a secret and turns on that role. It does a cron job, and it turns itself off. And so I have a fleet of single-use, quick action, quick to boot, persistent, consistent machines, and it's just a fleet of runners. With that, I can use Kubernetes, jobs, and still have Kubernetes orchestrate my little GitHub runners. And so if it fails, Kubernetes fails, it runs it again. And so I can interact with my little running system and create a whole bunch of builds, and I can start to add in just little single-use pieces, all scattered throughout the infrastructure around my team, and they have buy-in because I've made it easy for them to interact with. And so in summary, the edge network is significant, and it's something that you should babysit, and it's something that if you manage correctly, your customers will enjoy, and you will enjoy as well. It is difficult to manage, and as your service grows, the complexity and the size of your edge network hopefully is going to grow as well. There were inherent problems not to use Nix, and that's what we're overcoming today. But those are gone. AI happened, and two things happened with that. All of our bosses are now comfortable with approving uncomfortable things. That's just the reality of it now. They're approving AI slop. And guess what can be part of AI slop? Use Nix. They don't know what's in the code. They don't know the infrastructure it lives on either, and they're rubber stamping it. Let's use Nix. Because in this, I'm using it because I trust it. I came from out of industry. I understand process and I understand automation. However, I missed containers. I came into the cloud after Docker. Kubernetes is an amazing machine to me that I finally understand enough to interact with it, and I love it. But there's inherent problems with all of this. I love running workloads in Kubernetes. I hate finding the workload that failed. And so in all of these abstract systems, I've lost that intimate touch with the data. I've lost the intimate touch with the infrastructure. I've lost the intimate touch of all of it. And I'm just observing it now. And the only thing that I can trust in all of this abstraction is a configuration or a flake.nix file, because it's all explicitly listed. And when you have it peppered around all of these abstract systems, it's like bumper cars in bowling. You pull out the little bumper and you keep this abstract system going down the middle of the lane. But if you don't have these rigid constraints built around all of these abstract systems, there's no comfort there. And so what's crazy to me is when I first looked at Nix, I saw chaos. And now I see order, because the rest of the systems around it are getting chaotic. And this is comforting. This is calm. And so in closing, again, my name is Craig Jackson. I work with a company called NetActuate. We do really get excited about infrastructure and cool, fun projects. So if you have a NixOS project, I can give you a base flake. Come and talk to me, the Phlox and the Planet Nix crew. They've been incredibly helpful. So if you have any questions about where to use Nix, where to put it in your infrastructure, how to convince your boss, how to get buy-in on your team, please come find me or them, and we'd love to talk to you and help. Also watch our GitHub, because I'm using Nix now. And so I'm going to start creating a bunch of flakes and workflows that just make it easier to consume. There's not a good example of attaching vendor data in cloud init on a no cloud ISO and have that data persist inside of a Nix flake. And so we're going to start creating examples as well, because we really enjoy this community and we're glad to be a part of it. Thank you so much.
Awesome. Thank you so much. We really enjoyed your session. And I like that you called out other people too. Like, something that I've really enjoyed about the community so far here is that everyone has been so warm and welcoming, and it says a lot about who you are as people, as builders, and just as conference attendees, and we really appreciate that. Thank you so much again for speaking with us. Wonderful. And I think we're good to welcome up Jacek if you're ready. We'll let you get set up. Sure, we can do. You can get set up. We'll let Jacek set up. If you have any questions for Craig, feel free to ask him. And if you need to go to the bathroom or anything, we've got 5 minutes. So we'll see you back in 5. That's a bit easier than setting up, actually. It's kind of nice.
Okay. Screen. Sounds good. Oh yeah, I hear something. Very nice.
Perfect.
Yes. Oh, okay. Like this.
Yeah, I think that should be good.
Okay.
Now I need a second. There we go. Hello, friends. We are ready to get back on track here on track 1. So again, thank you so much for joining us today. And who's ready to get started? Yeah, love it. All right. So I will be handing off to Jacek. Thank you so much and enjoy.
Thank you. Thank you for a nice introduction. Yeah, so hi, I'm Jacek, and I'm here to talk with you about a test driver. Actually, we do that today like twice. This is the short talk. My goal here is to tell you things about a test driver that you might not have heard about it. It's a really powerful tool. Also give some oversight on what's new there, what's the architecture, where to look if you would like to study it because you feel intrigued and stuff like that. No demos, but today at 3:30 we do the workshop, and there that will be all about demos. So this is like very theoretical and later very practical. If you find anything here interesting, please also join the session later. Okay, one word about me. I'm the founder of the NixOcademy. Operates under the Applicative Systems Group label here in the US and in the European Union. We've been training more than 600 people in the last 2-3 years in Nix and NixOS, so really help organizations ramp up on Nix. Very often, I know from my own experience, that takes years. If you want to take it months and have everyone the feeling like, again, like why Nix is important for them too, not only for the org, we can fix that. There's a price tag to make it in months. And we have several organizations where we trained all the engineers and they really ramped up on speed. So that's a huge ROI that you get there. So if you find ramping up your org difficult with Nix, contact us. We can help you fix that, like with all the other orgs. There's also the Nix Anti-Patterns book. It's pretty new. This is the last chance to get it for free. Outside on the table, please pick your copy. We used that as a little test balloon, got surprising, like overwhelmingly great feedback, so I decided to sell it now. But I think there's like 30 copies still left over. Get yours. Okay, about the test driver. So the NixOS test driver, who has already heard about it so far? Please. Okay, who has used it so far? Okay, a few. So the test driver is a Python app, essentially. And the problem that it tries to solve is to provide you a very simple way to say, okay, let's spin up 5 VMs with certain configuration. One might be an email server, one is a web server, and then you do certain things where you simulate a client to do whatever you like. The NixOS project also uses it to test their own installer, to test Kubernetes, to test MySQL, sharding, whatnot. Everything that can be tested by providing a little environment with multiple VMs that try to simulate some kind of real-life scenario can be modeled with this test driver. So if you need complex test scenarios that run quick, this is for you. In general, we basically have the driver. You are operating from the driver perspective, and then there's multiple Python objects like machine 1, machine 2 that you can access and start, stop. You can power cycle the machines. You can communicate with them via serial. You can log in via SSH when you want to debug. So there's different modes. One is the quick sandbox runs. One is the interactive mode. I will show it to you. You can even run graphical VMs and test graphical applications. You can make screenshots and stuff like that. So the test driver gives you access to all these things. And you can also run machines in multiple networks. So there's blue and red networks on this picture, which kind of shows that you can have multiple VMs running in different networks to, for example, test networking, routing, and whatnot. This is my favorite example of an integration test. It tests a BitTorrent service. So the BitTorrent service is basically peer-to-peer file exchange, right? And to test BitTorrent, what they did in the NixOS project, because transmission is the torrent client that's packaged in Nix packages, and there's also a module that you can activate. They set up a tracker where they have a transmission client that kind of seeds a file, and then they have Apache serving the torrent link and OpenTracker coordinating all the file shares. And then they set up a client that is in this red network. So that simulates a home network subnet, and the blue network simulates like the internet. And this client is behind the router, and then they would kind of transfer the file. and then they switch off the transmission client and the tracker and switch on the transmission client and client number 2, so that the file needs to move from here to there now, which is behind the firewall. So they also test how transmission unlocks the port here via mini UPnPD and so on. You can imagine that we're not only testing BitTorrent here, we're testing NixOS network configuration, we're testing Apache, we're testing OpenTracker, we're testing net routing settings, we're testing UPnPD and stuff like that. And that is a pretty complex scenario here, actually. And you can imagine that NixOS can actually reach this high packages per maintainer ratio and keep them up to date and running, because there's so many tests that track this stuff. And it gets very apparent when something breaks with a little update. However, the infrastructure that we define here is defined in roughly 50 lines of code. You just need to write 50 lines of code. Asterisk, I'm removing all the bracket line noise kind of, but the actual code is like 50 lines that describes all this infrastructure. It's just a few NixOS configurations shoved together, and that just works. There's another 60 lines of Python that does the test script, like create the file, share it, blah, blah, blah. And the whole test runs in below 2 minutes on your laptop now. So this is kind of the simplicity and power of this framework at the same time. There's also graphical tests that you can do. My favorite one is the Google Chrome test in the upper left. So Google Chrome is one of the first browsers that puts tabs into each processes and isolates them from each other. And they are calling that sandboxing. And the thing is to test if your Chrome is properly configured at build time and running with sandboxing enabled. That means that you have to run Chrome graphically. There's no command line flag that gives you that. And you go to Chrome://sandbox, and there the page says you are adequately sandboxed. What this test does is it runs a graphical VM, runs Chrome, clicks into the middle of the window, runs copy, pastes it into a buffer, and then grabs out of this buffer if you are adequately sandboxed, yes or no. And the test is parameterized on different binaries of Chrome. It's really small, and it runs also below 2 minutes, I think. They also test multiplayer games for the client-server connectivity. They also test GNOME, and there's kind of text recognition too. You can make screenshots of a running VM, and you can also check if there's certain text graphically on that thing, which is really amazing. Sometimes I put QR codes on these slides, so we have on the nixacademy.com blog examples of this that go more into detail. What is also really interesting is that sometimes people say like, okay, yeah, Vagrant also enables me to build multiple VMs, but I wouldn't build a test with that because that means 5 VMs means 5 VM images that takes ages to build. And then imagine the build infrastructure. If 100 developers do that all the time, you have like thousands of images clogging the disk. What is apparently interesting, and I'll show you that in detail later in the workshop session, we're not building any images. With the BitTorrent test that you've seen earlier, we would build the so-called top-level derivations. So that is a set of store paths that get thrown into your host's Nix store while building that stuff. When we launch those QEMU VM sessions or processes, we just map the host's Nix store read-only into the VM, and it selectively boots those paths to get its configuration there. So you change the configuration from a BitTorrent test here and there, change some host name, whatever, and rebuild, and you're running in seconds again. There's no images. So this is really quick, really fast. It's really different than other tool sets. This is how a test looks like. I have a manual one here. So when I said earlier that BitTorrent just needs 50 lines of code, I was referring to the blue part here. That's the list of nodes. What's interesting here is we're saying machine 1 exists and machine 2 exists, and you're abbreviated, you just add a lot of config that can be random NixOS config. And then what the test driver does later in the test script, which is the imperative part, so that is declaratively describing your existing infrastructure without running yet. And then when it runs, you can start the machine, stop the machine, do whatever you like. Here, because we named them machine 1 and machine 2, we get a machine 1 and machine 2 Python variable. And here this is real Python. I exaggerated it a bit with the for loop, but it's to demonstrate that we're using real Python here. You can also import your own packages and so on and so on. And not only get Python variable names here, you also get DNS names. So one machine can ping each other using those names as you describe them up here. So there's a lot of default settings that are taken off your shoulders to quickly get something running like this. As you can see, this is just an attribute set with an attribute name, nodes, and test script. That isn't in derivation yet. You typically run it through packages.testers.run NixOS test, and that creates the derivation that puts the Python app with your VM configurations and everything together, and then can run them in the sandbox that then produces your test fail or not fail result. So that typically happens in one big step. And that's as simple as that. The tests then run in the sandbox, right? So the Nix builder typically builds whatever you like, PDF files, package compilations, repackages Python stuff or whatever, or it just runs 20 VMs in the sandbox. It doesn't care, which is pretty cool because this way tests don't only become very reproducible. It's also that your build infrastructure becomes your test infrastructure. So in many companies, build and test infrastructure is something different and separate from each other, and test infrastructure is really complex. But when you use Nix and accordingly design your infrastructure, you just have a huge set of builders that build and test and do that very quickly. What's also cool is because the builders just run the same thing in the sandbox as you do. If your CI goes red because some complex test failed, you would just reproduce it on your laptop and then fix it, and the first commit that you push already contains the fix that made it work. So there's no more the CI is the single source of truth, and I'm committing and pushing and hoping, and oh, it still didn't fix it, so commit and push again and again and again, or press the replay button. You're liberated from that. Everything that runs on your laptop will also run on the CI. This is the interactive mode, so if something fails, you can check out the test, and let's imagine you have a test that runs for 1 hour, and then you fix something. Although it runs locally, you don't want a feedback loop that goes for 1 hour or 2, whatever. The interactive mode allows you to run a test the same way as it would run in a sandbox, outside the sandbox, and then the VM windows pop up in front of you, and you can log in into them individually. You can SSH into them, you can play around. So if something fails, you can look at the logs, you can install more debugging tools, you can really dig deep what the test problem was, fix it, and then run it in the sandbox again, finally commit and push it, and it's gone, it's done. So this is pretty cool because the interactive mode also has this nice text completion, so you can find out what is there, how do the procedures work, and then find out how to even test your software. So while you are playing around, you can take your notes and actually set everything in stone for the actual test later. So this is really useful and really easy to use. Integration tests also run on macOS, because macOS can, of course, run QEMU natively and then run your VMs inside there. So that is supported. Nix packages itself contains more than thousands of these tests. It's like last time I've seen with counting the lines in the NixOS/tests folder, it was 1,100. So there's nothing that hasn't been ever tested. So if you kind of are like, how would I do that? You could look into this folder and check out other tests and get inspired from that. There's wild scenarios that are elegantly implemented that you can kind of use for yourself. The architecture looks like this. Sorry, I think the text is a bit too small. So in general, you have like 2 profiles, the QEMU VM profiles, which also work without the test driver. So you can quickly import the QEMU VM profile in NixOS config and then spin up a VM in front of you and play with that. The test driver just makes it so that you can orchestrate multiple of those and put them into a network, which is of course a little bit more complex. What's new is there's also a systemd nspawn container profile that also works alone, and we can now use both. I will talk more about containers in 1 minute. The test driver is just put on top of that. The test driver is basically a Python script that's bundled with some configuration that can run 5 or 15 VMs and wire them together, right? And the configuration of the test driver is also not trivial, so I have the test module system. What's interesting, if you want to learn about that, in the NixOS modules folder under virtualization, you see those profiles. These are worth studying because they are also worth without the test driver. The test driver Python project is under NixOS/libset test driver. And then the packages testers run NixOS testing with the attribute set that automatically wires everything together. That is under NixOS/lib/testing, which is also documented because it uses the normal NixOS module system like the NixOS modules too. And that together wires up the whole powerful test driver framework. There's also new debug hooks. So that is a feature that's really worthwhile mentioning, because sometimes people told me like, look, we have tested one like for 5 hours and then they fail, but they never fail on the laptop. So what to do? You can enable the debug hook and configure your Nix builder accordingly. And then when it fails, like next week or something, then you can log into the builder and the test is being frozen for you and you can actually log into the machines. There are some complicated lines here. The test driver will print them for you. It's just to be mentioned here for you that you can actually freeze failing tests on remote infrastructure if they are hard to grasp why they fail. Then you can log in and debug the hell out of it and finally fix it. So that's relatively new. Container tests. So customer asked me like last year, how would you do GPU testing in the sandbox? And we discussed it a bit more, and then we realized, look, so if you could kind of add containers to the test framework, that would be more than you're actually asking for. But it would make everything also interesting for the public. So the public would gladly accept that into the upstream Nix packages, and then you get what you need, and you don't have to maintain it, because the community thankfully accepted the whole thing, kind of, and everyone profits from that. Shall we try that? So they were like, yeah, let's do that, and now it happened, so we are nearly merged. We can now run containers. What that means is that instead of running QEMU VMs, we just run systemd nspawn containers, which are faster because you don't have the overhead of a new kernel and hardware models and stuff like that. And the cool thing is, instead of writing nodes.machine name equals blah, 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 you say containers.machine name equals blah, 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 and that's it. You can basically switch over many tests if they're not graphical and so on. What's also nice is that you can combine VMs and containers, and these are kind of fast and light, right? So you cannot run 150 VMs on your laptop, but you can always run 150 containers. It's possible. Also, we are kind of relieving people that used the test driver before to use bare metal infrastructure, because you need KVM acceleration, and typically nested VMs don't work well. So you needed bare metal infrastructure to run NixOS tests quickly. Now you can use cheap VMs, and they just run without overhead with containers. So that's a huge liberation from certain hardware requirements that we don't need any longer. And the final goal for our customer was that we can now map GPU devices from /dev/blah, blah, blah into the container, into the VMs, and run CUDA in the container, for example. This is kind of the CUDA example. Sorry, I didn't know that the board would be so small. We have containers.mycontainer equals NixOS configuration. And here we installed SCaLE. That is a minimal CUDA application to test if CUDA is configured at all. And here's a list of paths that we make available from the host into the sandbox and then into the container. So you just need to list them up. And then in the test, we basically run SCaLE. And that program would crash if CUDA wasn't available, but here it doesn't. And that's it. So we can run CUDA stuff inside the NixOS integration test, which is pretty cool, because many real-life products are deeply embedded in some NixOS configuration. And this way, you can finally have very production-near scenarios on your laptop, basically, or whatever hardware has NVIDIA cards. To enable this, we need to set up the Nix daemon in the config. So we need to allow for auto-allocate UIDs and cgroup stuff. The thing is that systemd needs to manage a lot of like mappings between user IDs, identities, and stuff like that. It's really complex. You can also not run any SUID stuff inside that, but even Lennart Pöttering, the main systemd maintainer, started hating SUID, so that will most likely vanish anyway. We're a little bit at the edge, kind of, but this will improve anyway, and it works pretty solid and well. Upstream container support will be available in 26.05 in a few months, but I expect the pull request to be merged in a few weeks already. There's a lot of review that happened and improved it very nicely. And I have an example test, as you see later, 2 containers pinging each other and then dying again is 2.4 seconds in total with all boot stuff and so on. Special thanks to the Clan project, who wrote the first proof of concept of container tests, and also JFly and Kmine, who worked for us to implement this in an upstreamable way, which was a lot of work, but they did that so perfectly. And Mar27, he sits in Stuttgart, works for Secunet. He helped us review that stuff, and he also exposed some more optimization potential which made this amazing. If you want to try this out now, check out the Nix packages fork of applicative systems. It's in the branch NixOS test containers. We'll do that later too if you want to see it. One word about the NixOS documentation. People typically find out that when you Google stuff about Nix packages or NixOS, you find nothing, just blog articles of people and so on, but not the primary documentation. That is because the Nix packages docs and NixOS docs are one huge HTML document, so large that Google does not index it. So until that is fixed, please bookmark these pages and use Control F inside, and you will immediately find what you need, because everything I just talked about is documented already. It's just that you can't Google it. That's the only thing. Last slide. Thank you for listening. So we do NixOS training and consulting. I loved this project because we had a customer sponsor this nice open source stuff, and everyone profits from this now. And our lever was that we, of course, know the right people, so who to nudge to get complex changes upstream and to redesign this in a way that's actually upstreamable. That we really much enjoyed that. Yeah, so there's also our newsletter. So you can scan this QR code or look for Nix Academy newsletter. We typically send monthly updates on what happened in the blogosphere with nice summaries for people who are thin on time. Thank you for your attention. Do we have time for questions? Okay. Questions, please.
Hey, really cool talk. I didn't realize all that was there, and I just recently re-implemented it all, so that's disappointing.
I'm glad you like it.
Although I did do Minikube as well, so it does like Docker, and then it does Minikube tests, which could be, we should talk. But my question is, that's great to see all the CUDA automation, but, and you've also got graphics in, right? So maybe we could actually test the NVIDIA display drivers working inside NixOS.
I mean, to test GPU stuff inside QEMU, you would have to map the PCI device into the VM, which is of course possible. No. We talked about doing that with containers, which relieves you from actually exclusively taking the whole PCI device. You can just map the /dev/NVIDIA blah 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 paths that are available on the host and share them with other applications running on the host, which makes it much easier. You could, of course, do what you just said, but you would have to rip the whole PCI device logically from the host system and into the VM. For our customer, that was not feasible. But it's generally doable, yeah.
I think we have time for 2 more questions, if anyone else wants to ask. Yeah, okay, I'm coming.
Yeah, so earlier you had said that you can run NixOS tests on macOS, and I saw this on Discourse when it came out, and you were involved in getting this merged. But to my knowledge, you still need to have some way of building the VM. And previously, that meant like installing Nix Darwin, having the Linux builder, and then doing this. Is there another way?
What you just described is the easiest way. So the question is, can I just run out of the box macOS NixOS integration test, yes or no? No, you need to prepare your macOS to do that, because macOS can run these tests, but not build your VMs natively. For that, there's a Linux builder. It's really easy to set up with Nix Darwin. It's a 5-minute process. We described that in this blog article here, if you want to have a look. So it's generally doable. You just need a quick setup first. Last question.
Yeah, last question. All right, I think we're all good. If there's is there anything that you wanted to share that you didn't get a chance to say?
Thank you for giving me such a great time here. I really love being in the States. Planet Nix is an amazing conference, especially when you compare it to NixCon. There's some nice trade-offs, and I really enjoy being here every time.
Thank you so much. All right, thank you so much for joining us, everyone. We're going to cut to a lunch break. You have 90 minutes to get lunch, and then we will have sessions in track 1 and track 2. So thanks again. See you at 1:30. And also, Jacek does have a workshop later today, and...
Can I say one other thing? So we not only distribute the book, but also we have these Nix stickers. And what's not apparent when you look at them, the QR code is individual per sticker. So that means you can scan it and then claim the sticker with your GitHub account. And when someone else scans it, they see your GitHub account and your achievements in the Nix community, because we track all the pull requests and issues, all the public data. And if you ever contributed, it will be visible on that sticker. Thank you.
Thanks again so much, and we will see you back here at 1:30. Bye, friends. Hello, friends. We will be getting started soon in both room 1 and room 2. So if you can hear me outside, please start making your way in. We are excited and getting ready to begin. Hope you had a great lunch, and thanks so much. All right. Hello, friends, and welcome back. I hope that you all had a wonderful lunch and you had some time to rest, recharge, eat some food, and get ready to learn some more. Yay? Nay? How we feeling? Yeah? That's good. So, thank you again for joining us. Thank you to our sponsors who, without them, we could not have made this possible. Thank you, of course, to the audience because, again, if you weren't here, we couldn't do this. So thank you so much for joining us today. And with that said, I'm going to hand it off to our first speaker of the afternoon. Please give a warm welcome to Burke.
Thank you. So I will admit I procrastinated making slides for this for quite a while, and I did eventually get a slide deck put together. but I kind of decided yesterday, you know what, I'm going to do this whole presentation in the terminal anyway. So the thing I want to talk about is how Shopify is using Nix to power its monorepo. And I'm going to show you first, I'll go into our monorepo root here, and I'm going to run run this thing. And here's my slides. So we're going to talk about tectonics. So Shopify in 2024 decided we were going to be a monorepo company, and this is kind of the story of how that came to be. So I guess by way of introduction, I'm a principal engineer at Shopify. I've been around for 14 years now and been responsible for most of our generations of developer tools. Some of you might remember me from NixCon 2019 in Czechia. I gave a talk there about how Shopify was adopting Nix to power its developer tools. We had been kind of gutting our existing kind of convergent tool. So we have this tool called Dev. We did that, and we still do actually, that operated a little bit like Chef or Puppet. And we thought we would replace the internals with Nix to deal with these problems you start getting to when you have 1,000 developers and they can all break their machines in fascinating different ways. Nix solved that problem quite nicely, but we stopped. This talk is three parts. There's some context about our journey with Nix and the monorepo adventure, and then 2 technical bits, technics and tectonics. So we were hollowing out Dev to replace it with Nix. The promise is this reproducibility across thousands of machines. The problems we ran into are like, Nix is really hard. It's hard for me. It was hard for me to learn to build this stuff. It was double hard to teach to everybody in the organization when they would run into the rough edges with it. Nix also wants you to go all in. It's very difficult to use Nix in a kind of piecemeal way, or at least I was not up for the challenge in 2019. And the organization wasn't really willing to bite the bullet to go all in on Nix. I wanted to kind of sprinkle Nix a little bit to power our development environments in a way that, at the time at least, I felt like Nix was fighting me on that. We tried to paper over all the sharp edges, and ultimately, I wasn't able to pull it off. Made some kind of strategic errors that annoyed some critical people, and we decided, you know what, we're done with this project. We're going to roll it back. This was not the thing to do at the time. So, was that the wrong decision? I think not really. It was, at the time, the effort reward for us was, the reward was kind of there, but the effort was so high. And we were starting to get to this point where we were going to have to teach our users more about Nix, and they just wanted to ship their code. It was a pretty high burden to subject them to at the time. So Nix, as you're all quite aware, has a fairly punishing learning curve, and we didn't feel like there were great resources to teach people Nix at the time. So we put it aside. But then 2024 came around. This is maybe 4 years after we dropped it. We were sitting around at a very large room in Toronto with something like 6,000 people or something. And it was hack days, so company-wide sort of hackathon for 2 days. Chatting with Toby, the CEO. Toby is an engineer at heart, and he gets very into technical details around the company, and especially things that are like very obsessively nerdy, such as Nix. He says to me, you know what I really regret? Killing that Nix project. I was like, okay, great. But by the end of the day, we had decided, using this kind of like hack days energy and all of the sort of ambition in the air, you know what? Like, we actually have to be more ambitious about our developer tools here. What we're going to do is, like, right now we're deciding that we're readopting Nix for our development environments. We're going back to local development. And this one is a little bit there's some context here that I'm not going to fully fill in, but we had some cloud development environments that led to these really artisanal configurations that it's not super relevant to the story, but dropping that put us closer towards the Nix dream too, kind of. And we were becoming a monorepo company. This was arguably actually the biggest of the three things. This is a pretty consequential technical decision, and we decided we were going to sort of jump in on that one with both feet. And a sort of consequence we derived from this one is, well, if we're using Nix for some things, we may as well use Nix to be the build system for the monorepo as well. So this is the path we took. So why was this a good idea in 2024, but not in 2020? Honestly, it's that Claude will write the code for us now. Like, this whole thing of it being a pain in the ass to learn Nix being complex, running into these errors that you just feel sort of stonewalled by and unable to get past. I notice, you know, I can easily remember the days of feeling this way myself, but I notice it so clearly with users when they're not leaning into these tools. Is like, Nix has errors that can feel fairly disempowering, but it sort of doesn't matter anymore. If you toss Claude at these things, your problem is solved. They can write the code for you if you don't understand, right? They might not necessarily be able to implement the guts of this system for you, but you can certainly craft the system in a way that your users can unblock themselves. The learning curve now kind of is someone else's problem. So this is what we basically realized, is software is free now. And this isn't just about Nix, but I do think Nix disproportionately benefits from this, because all of the complexity that made Nix hard for humans sort of doesn't matter, but all of the benefits that Nix has always had, that, you know, we sort of adopt Nix despite these horrible complexity trade-offs because of these incredible benefits that have still somehow outweighed the cost. The equation tips so far in Nix's favor, in my opinion. So monorepos also have relevant advantages here. When all your code is in one place, you can just drop Claude or whatever at the root of your monorepo, and it, as long as you coach it correctly, knows everything about everything. You can make cross-cutting changes happen in one pull request. There's no negotiating across API boundaries as long as we're talking about build time dependencies. You can atomically change publishers and consumers of a library in one go. This makes it really easy to do cross-cutting refactors in a way that is difficult, or more difficult, at least in poly repos. There's another thing that has been, like, raise your hand if Git work trees were a part of your life a year ago. Right? A few, yeah. 20%, 25%, yeah. Like, who uses Git work trees now? So like 75%. So this is something that, well, especially in a monorepo with agents, you really start wanting work trees. And I find Nix lends itself really well to work tree style development too, if you're using it for development environments, because it depends a lot on how you build your development environments, but the way we were doing it before, at least, had a lot of things that would be sort of wastefully duplicated across work trees. And now with Nix, this is just a symlink to a thing that you already have in the Nix store, and it takes whatever number of milliseconds. So this is cool. The dream basically is anywhere in any work tree, in any zone. We call them zones. Fun story about our monorepo. You want to divide a monorepo up into some kind of package, right? Package would be a good word, but Nix definitely already claimed the word package, and we cared about not conflicting with Nix. Every other good word for what you might decide to carve up a monorepo into was taken by something important in Shopify, so zones is what we call them. It's fine, I promise. So yeah, Fareed. Yeah, shoot. Yeah, it's some of this is still. So the question is, Nix doesn't exactly describe like. Nix is a little bit bring your own build system. How are we doing the build systems for the various language ecosystems? The answer is it's a little bit ad hoc, and we get to punt on this question a little bit because being a predominantly Ruby company, like where most of the biggest projects care mostly about Ruby, which famously does not have anything resembling a build step, we get to sort of let this crystallize a little bit later in the process than other companies would. So the sort of philosophy we're trying to apply here is we would like to, as much as possible, preserve the user experience of the existing ecosystem package managers and wrap and patch them in whatever way it takes to make them collaborate with Nix to do whatever it seems to be that we need to. But yeah, the dream is basically we run dev up, which then calls Nix to do something, and we get instantly a development environment from wherever. So let's talk about how we made that happen. Part 2, Technics. So our Git repo is currently 30 gigabytes. This is the Git directory itself. Even after splitting out everything on import that exceeded some size threshold to be an LFS file, it's fairly polyglot. It's like, I've mentioned we're dominantly Ruby, but there is a whole lot of TypeScript, Rust, Go, some C++, you name it, there's a little bit. The thing about a 30 gigabyte Git directory and over 1 million files is the Git index does not love that if all of that is in your checkout. Every operation starts to become miserably slow. A Git checkout can take upwards of 20 seconds. Git status might take 7. So we use sparse checkout. And we specifically use sparse checkout in cone mode. The only reason we're actually able to stay on Git here is that Microsoft front ran us a little bit on this by making some performance patches to Git a couple years back to make it sort of borderline reasonable for them to put Office and Windows in Git. So we've benefited a huge amount from this, and we're using sparse checkout in cone mode. And what cone mode is basically you specify a subtree root, and then everything under that subtree appears in your checkout. Everything that isn't in one of those patterns does not appear in your checkout. So that works great, especially because we sort of carve up our monorepo into these, what are the same as cone shapes called zones. So here's the challenge, though. We're a Nix-based monorepo. You are some code in zone A. You want to evaluate some Nix code that depends on something in zone B. Zone B is not checked out. What do? Right? You can't just import /b/default.nix. So here's the false path. Our first solution was fairly hideous. The basic idea was we're going to use import from derivation to just like call git show to get a file called zone.nix from that zone for every zone that we want to depend on, every build we want to do. It totally worked, but it was miserably slow. But we kind of built this with the philosophy of like, first we're going to make it work. We're going to design the user experience that we know should be possible. Then we're going to figure out how the heck we're going to make it fast later. So that's what we did, and we limped along with that for months, and it was sort of fine. This is actually the code that that made that work, and I'm just going to linger on this for a little while because it's hideous. So at the bottom you'll see git show. This was a function that got called kind of indirectly from some other places, and really all it did was git show object to out, right? But you can see the build inputs has world git. World git in the middle, what this is we're going to specifically call git with a git config that passes a git directory of the prescribed clone location of world, our repo. But home, right, this repo, the prescribed location is under the user's home directory. And of course, Nix builds run as the Nix daemon. So we don't know what the home directory is. So we also had to do this terrible black magic to figure out what the user's home directory is, which was, it turns out if you stat dev console, you can figure out who is logged in. So please never do this. Anyway, that worked. We also actually had to set an ACL on the user's home directory so that Nix would be able to traverse it. Just don't do this. This is a case study in what to never do. So that worked, but now how do we make it fast, right? Maybe, I've heard dynamic derivations maybe sometimes replace IFD. Is that relevant? I don't know. Disable SIP and use fuse, I guess. I don't want to make even more enemies in the security team. Maybe we could patch Nix? So I kind of realized software is free now, so why don't we just patch Nix? And that is what TechNix became. It turned out this was actually really easy. So what we have now is we have our little fork of Nix where we pass another flag, tectonics git SHA. And then we have some new built-ins. In this case, one is called, I tried to make these very unappealing for our users to call directly. You can see, anyway, unsafe tectonics internal zone source. So we pass it a zone path. Our zone paths start with double slash, like a Bazel monorepo or whatever. And this gives us basically an accessor to the source. We can pull a file out of it. We can import it much faster, way better. And this gives us the imported file. Big improvement. Here are the built-ins we added. This doesn't really matter, but just maybe this gives you a sense of like the flavor of what we did. We have a manifest at the root of the repo that sort of just enumerates all the zones. And so we have that, and then an inverted version of it, and then a thing that gives us a source given a zone, and then some other stuff that doesn't really matter for the purposes of this talk. Actually, one thing that maybe does matter is you'll see a couple things here like sparse checkout routes and dirty zones. One of the things that Tectonics does is it sort of flexibly decides whether it's going to pull the source of a zone from your local checkout or the Git directory based on basically whether there are uncommitted changes. So it tries to be intelligent about building from the local checkout. Yeah, Fareed? Mm. Yeah. Yeah, so the question is, we're just mostly concerned with providing environments, so couldn't we have stopped before Nix build? So one of the things is that the monorepo is sort of self-describing, self-implementing. So a lot of our tools are actually zones in world. So they are built as builds and then provided as the actual like profile of tools that gets installed as the base layer here. Some of them come from, a lot of them come from Nix packages, but a lot of them are actually like monorepo builds. So one question that came up, actually repeatedly because Toby kept asking me, was why not use flakes? And it sounds like a very sensible question. Like flakes are the thing, why don't we use them? They seem like they're maybe shaped like this problem. So we had two choices basically if we wanted to use flakes. We could put one flake at the root, but then maybe I didn't spend enough time thinking about this, but this doesn't feel like it makes sense to me because you certainly encapsulate all of your inputs nicely, but then you sort of, it doesn't feel like you've gained a lot really because you're not solving your like, your problem. I think there's maybe like sub flakes or something now. Maybe I could have looked into that. The other thing is like if you have one flake per zone, that totally feels like it solves this. And it kind of does. But the problem is then you have, every time you want a zone to depend on another zone, you have an input registered there and that has a hash. So then if you change something that's like deeply transitively dependent on, you have spidering hash updates all across the repo, possibly including a bunch of files that aren't even in your sparse checkout. So you would end up with, especially as you grow to be a more sort of like deeply in-webbed kind of heavily depended monorepo, you get to this point where you have a fairly ugly kind of pull request process where you get these hash updates scattered everywhere. All this on top of the sparse checkout conundrum, which like I don't think we'd easily be able to make flakes handle the fact that the flakes they're depending on are just not there. So the kind of key insight here is we're building a trunk-based monorepo. Everything depends on the concurrent revision. So if you're operating at revision head and you're depending on zone ABC, you are depending on zone ABC at version head, and there is no other option. So in this context, Git's Merkle tree already provides consistency. You don't need a hash to assert that you're like maintaining your version integrity. It's just implied by the fact that you're operating at the same Git commit. Flakes would duplicate this. So I made that case, and then Toby pushed back again. He says, well, you know, that's fine, but Flakes have lazy trees. It's like, it's a real shame to miss out on those. And having an engineer CEO is awesome most of the time, but it's really annoying when he's right. And so then I kind of, that really got to me because it was annoying. Like, lazy trees are excellent, and I really wished we could have just had them. But I realized that I could just make them work in Technics, and I did. I just opened Claude and I said, can you make me have lazy trees? And it said yes. So that was surprising. So yeah, Technics is now a fork of Nix. And I mean, obviously that only worked because the lazy trees code was excellent. So thank you. But yeah, so Technics is now a fork of Nix. Really, it's a set of patches on top of determinate Nix that we just maintain because that's easy too. It has this sort of like monorepo SHA concept. You know what SHA you're on. It does all this Git object database integration with libgit too, which I don't exactly love, but Git doesn't do a good job of being a library, so that's what we're stuck with. It does a lot of caching to make it all fast, and it has lazy trees. Delightful. I sort of mental model it to myself as like what if Flakes, but designed exactly for our monorepo. It's like, it's kind of open source, but it won't be directly useful for you, but I don't know, maybe it inspires something. So then the other part is tectonics. So it used to be the case that I thought of tectonics as two things, the kind of like guts of our monorepo and the other thing I'm about to describe. The guts of the monorepo sort of got extracted out into Technics. And so what tectonics is pretty much now is the build system, the module system. And there's a fun thing about this word that I just want to highlight. Tectonics is a triple entendre, which I'm super proud of because I accidentally woke up in the middle of the night and had this idea in a dream. So, yeah, it's like, you know, our monorepo is called world, so it's, you know, tectonic plates, the foundation of world. Also, tecton is the ancient Greek word for builder. It's a build system. And then, very prosaically, tech2nix technically makes it a triple entendre, even if it's not a very exciting one. So it's a module system. Basically, this is, we use the NixOS module system, types, lib, bunch of stuff. But we define our own modules, kind of similar to devenv, quite honestly. Every zone has a zone.nix file. This configures everything, like languages, dependencies, CI, development environment, and everything flows down through progressive refinement. So basically, what tectonics does at the end of the day is there's a whole sort of progressively concrete level of options that you can assign that all bottom out in assigning to an attribute set called targets, which is just derivations. And everything you could possibly do with tectonics from the sort of outside perspective is pulling out something from the targets attribute set, and that's just a build. So if I would run this command, tech is our orchestrator for tectonics. So tectonics is a Nix code base, but we don't suggest to people that they literally run the Nix command to build things. We re-expose it as this tech command, which has, I don't know, something like 15 subcommands, but the relevant ones to point to here that kind of give you the major mental model are build and run. So if I run this, tech build areas tools tech default, what this is going to do is it's going to build the module system for this areas tools tech zone. look up the targets attribute set, pull an item called default off of it, and then run nix build on that, basically, and then give you this thing back out. So an interesting thing about this, though, is this works, I mean, as I've kind of alluded to, this works regardless of whether or not the zone is checked out, because it'll read directly into the object database using lazy trees. But another thing is it actually works even if world isn't cloned on your disk. And that's a little bit surprising given the mental model I've handed you so far. The way that works is tech actually collaborates with this other piece of software called Windex. And what Windex does is it's a cache that gets filled by our continuous build servers that takes this input of a zone ID. Zones have IDs too, it doesn't matter, just think of it as a zone path. Target name, get SHA, platform identifier, and it's basically just a key value store that resolves that to a nix store path. So given this output, we can just try to like nix store realize that and presumably fetch it from our binary cache. So knowing these 4 facts about what you want, which are totally inferable from the command line where I ran tech build. You can check. This is nice too because it short circuits the whole nix eval step. So now rather than being like 2 to 7 seconds or whatever, it's 50 milliseconds. So it's filled by continuous build servers, no checkout needed. If it's been built at that SHA, Windex has it. So there are I made this up for this slide, but I think I stand by it. 3 principles that I want to hold to in tectonics. So meeting the user where they are, letting the agent write the code in the zone.nix for the most part, and feeding back on variants. So let's talk about those. So number 1, meeting the user where they are. If you ask a user to like describe a zone, especially like a small project, right? Like if somebody just writes a library and it's like 100 lines of code and they did it in an hour because it was just sort of extracting a thing. If they describe to you what that thing is, they're going to be like, it's a Ruby library. There's nothing special about it, right? And so your config for that zone should look a lot like, it's a Ruby library. There's nothing special about it. Or even, you know, simpler. We're playing around with a few different like high-level syntaxes here. The idea is what we want this file to represent is the intent, not the implementation. In a monorepo, you don't have to lock versions exactly because you don't have to deal with this whole like producer repo, consumer repo thing. You have atomic changes across the whole thing and you have CI that can trigger across the entire repo when you change anything. So if bumping nix packages breaks your MySQL, you can do this thing where you can actually just leave it fairly loosely specified, but then discover upon attempting to bump that you now have learned that you no longer had meant to just give me MySQL, you now had meant give me a specific version of MySQL. So there's this kind of like retrocausal intent thing going on where you can sort of discover that you actually had meant a different thing prior and now we pin it for you, right? And this gives you an interesting thing because you now, this sort of like calls forward to another point that I'll get to in a minute, but this gives you an interesting thing where you can sort of like see the increasing complexity of configs and treat that as a signal that like maybe this project has drifted and there's a sort of reunification of standards that we could do. This is the big one that has changed our attitudes about Nix this time around in 2024 and onward, is in, you know, before humans would write this file, and we had to be very careful with managing complexity exposure because we have thousands of users and we don't want to have to make them all learn Nix. But now, basically, we can say, you can write it if you want, but like, here are some Claude skills that will configure this project for you however you want. Just tell it what you want. Complexity doesn't matter, or it does, but it doesn't matter in the same way. We don't need to teach users Nix, we need to teach agents our module system. And that's a very different problem. So I'll kind of get to one little aspect of that soon. But the third principle is feeding back on variance. So The complexity that we see in these zone.nix files across our hundreds or thousands of zones is a signal. If there's a file that's just a couple lines, that means we have perfectly captured the pattern that represents what that project is trying to do. If it's high variance, if they have a ton of code, it's suspicious. It could mean the project is genuinely unusual. It could mean we, the tools team, failed to capture a pattern. Or it could just mean that user had no idea what they were doing. In any of those three cases, it's probably good to at least attempt to reunify some of that. In some of these cases, you will have the genuinely unusual project. And you go, okay, this is actually fine. You're doing something weird, and it's good. We're not going to refactor this. But all these other cases are a signal that there's something not captured by the contract between your build system and your users. But this is all visible, queryable, all in the same repository, and it's very easy to make atomic refactors where you implement a library and refactor the consumer to use it in the same commit, and also prove that nothing has changed. So we can also make this queryable. And there's an interesting thing where NixOS has this options doc, options generation that's really cool. You can also generate a similar document that includes all of the current settings and the definition sites, declaration sites, the intermediate values that are all merged together. This is really cool. One thing that I'm kind of prototyping is, what if we evaluate this across all of the zones in the monorepo? Compile it into a Parquet thing. Parquet, for those who don't know, is like a columnar kind of data store format. It lets you encode highly normalized, denormalized, I can never remember which one. Repeat all the data, right? And just like dump it all in a bunch of rows and then just query it with SQL. It's just sort of magic. You can say things like, give me all of the zones where it's, you know, Ruby version 3.4.2 and higher than 1 CI parallelism or whatever, right? So this is kind of cool because now you can actually just generate that file, give Claude a skill to interact with it, and now you can ask questions about your whole monorepo and have this happen sort of magically, right? What zones depend on the deprecated money library? And that's now just a thing that Claude can figure out locally. So a lot of this was foresight, and some of it was a lucky bet. In 2024, when we were sitting around at that company summit, like, the thing that was motivating this really was we were speculating about this future and how at some point in the next several years it was likely to be the case that we were going to benefit a lot from AI writing a lot of our code. I think it came faster than we were anticipating. But we feel super lucky, or at least I feel super lucky, to have kind of made these choices at the time we did, because we're kind of right in this phase right now where we've shaken the snow globe and the snow is falling as we're like trying to figure out how to work with these new tools at the same time too. So I think like the preliminary results for us is I can say like Nix and monorepos both seem to be great choices for this era. And I definitely see Nix gaining ground in this ecosystem. I know we've all heard a lot about this over the last day and a half already, but it's like, it's so true that Nix is the perfect technology for the moment here. There's this effect, though, where like, when software becomes cheap to write, the thing that starts to matter is taste, right? Like the decisions about not can we build it, but like what actually should we build, and is this the right way to build it? Because software is free now. Nix and our monorepo are two parts, like the critical parts of making this actually true for us. Like stripping all of the toil out of our workflow so that we can focus on what we should build and whether it's the right shape. So we're building towards this world where we spin up an agent anywhere in world. Nix gives it an instant development environment, gets us to running the tests instantly. We have situational awareness. No onboarding, no tribal knowledge, no asking someone in Slack. It's just immediately productive. So that's the dream. We're getting there, and Nix and the monorepo thing have been critical in this. Yeah. Thank you. Fareed. Yeah, so we will have an application zone, and that'll be the part that the user is actively working on. It will have, in our case, often a gem file that will include gem like paths to libraries. And those will be when we run dev up or bundle install or whatever, that orchestrates Tectonics to build those into the Nix store from, it'll read from the Git object database unless they're on disk. So you can add them to your sparse checkout and work on them there, but by default, it's just like if you had a library that existed somewhere in rubygems.org, it's like the source is not super visible until you choose to make it visible to you. Yeah. It's both. Yeah, there's some sorcery here to just like make the ergonomics remain familiar while also allowing Nix to do the nice caching things for us. Yeah. Not really. I think if I had thought seriously about it, I would have suspected that my changes were going to be deep enough surgery that I would have tripped over it. But it felt so easy to fork it and so easy to maintain a fork that it didn't seem important. I'm trying to remember whether we enforce this. We don't have circular dependencies. We at least have not tripped over that yet. I cannot remember off the top of my head whether we enforce that continues to be true. Yeah. Okay, so if we were not limited, okay, so the sparse checkout thing is actually funny because I was just working last night on, the big problem is Git's index requires a lot of redundant work on every command. And I have a branch that I'm like working on to see like, what if this is just a memory mapped file that doesn't require any translation? Can I actually get away with a full dense checkout? So we might actually be able to pivot to that if I can figure this out. But the thing that I would do if we did have that is I would get much more paranoid about sandboxing these zones so they can't talk to each other. Because right now we get to be a little bit lazy about that because the files don't all exist on disk. We are kind of doing a halfway Nix thing where it's not the case that everything operates in a Nix build. Of course, once it goes to our continuous build server and we build certain artifacts, those are done in a real Nix context, and so they won't have a checkout that they can cross-bleed across. But there would be some worry there. Other build systems, we had actually been trying to use Bazel for our, especially TypeScript, for about a year before before we had this sort of 2024 moment, and had been largely unsuccessful with it because I think Bazel, even more than Nix, really insisted on you like Bazelifying your whole thing at one kind of cutover moment. And that was a difficult thing for us to like, A, do, and B, buy into the concept of wanting to do. Yeah, and like I kind of alluded to this before, because Shopify is such a Ruby dominant company, like we get to be a little bit lazier about our build systems. there are ecosystems that are more and less annoyed by this, but we don't have any like ultra massive compiled projects that need like really significant like distributed build infrastructure. It's possible we will in the future, but we have kind of some runway to build that as we grow into it. Yeah. Yeah. So I'm sorry, I've forgotten to repeat so many questions. Interaction with other build systems. So yeah, this is all kind of done slightly ad hoc. Like we're trying to use stuff that exists in Nix packages when we can, but we are, like, I think the stuff that exists in Nix packages by and large isn't excellent for like live development environments when you want to like convert a cargo toml into like a set of derivations. So I hope that the shape that we settle on some of this stuff for can be contributed back in some way, because what we're trying to build, which is all sort of in flight right now, is yeah, like a way that sort of flexes from development having this like familiar ergonomic and like not really compromising on any major workflows there, but then scales up to a sensible production build in a way that doesn't really cut corners there either. So it's an interesting thing to try to. I think we have time for one more quick question. Probably not in 1 minute. I'll try to encourage the guys working on this to maybe write a blog post about it. I think that could be helpful. Yeah. I think that's it.
Thank you so much, friends. I think if we had an award for the most Q&A in a session so far, you win it by a landslide. So we have a break right now, and we will be back at 2:30. So right after the break, we will have Steering the Future of NixOS. And Burke will also be back with Ilko to do a built-in SWASM talk after. So yeah, enjoy your break. See you soon.
Am I on? Am I on? Okay, I'm on. All right. Hey, everybody. The MC told me that I'm MCing, and therefore I have to actually abide to the times. So thank you all for coming back. We're going to go and kick off with a little steering committee and foundation panel. And I think most of the folks have already spoken today, but we'll do a quick round of intros anyways. I'm Ron. I'm one of the folks doing stuff on the foundation and also one of the founders of Phlox. And John?
Hi, I'm John Erickson. I've been working on Nix for about 6 years now, and Nix packages many more years before that.
Hi, I'm Philip Tarrin. I have been with Nix for 2022, 2023, somewhere in there. And prior to being on the steering committee, I was in the Nix packages CI that successfully got us all the way to you can actually click the merge button and it'll check your changes and put it in a merge queue. I reviewed the code. I didn't write it. Wolfgang wrote it. But I have, on a personal note, I have 4 kids at home and really enjoy this. And I work for a distributed file systems company, which is tasking me to switch them over to Nix, and is disappointed that it's taken me a long time because I'm a perfectionist.
Hello, my name is Julian. You can sometimes find me on the internet under the name Luge. My main occupation is I am a PhD student studying the impact of Nix on software supply chain security, and I've been in the Nix community for about 4 years, I think.
Hi, I'm Tom Breckney. You might know me as Tom Breck. I've been around in various corners of the ecosystem for about a dozen years. My main focus is that I think that Nix and things like it kind of give us superpowers to manage software as it gets more complicated. And as software gets more complicated, we're going to need something along these lines. So I am very focused on larger scale adoption and letting everyone know that these superpowers exist and bringing it to them, making it more accessible.
Sweet. All right. So run with the show, how this is going to work. If you don't ask questions, I ask questions. My questions are worse than your questions. So let's do that. Your questions can also be hard questions. My questions are going to be low ball, softball questions. So I'll kick off, but then start raising your hands. And I'm going to be both emceeing and answering my own questions, which is always fun, unless you ask the questions. So to kick off, we kicked off the SC kind of like a year ago. There was the new voting into the SC. Awesome people just joined the SC. What's kind of like top of mind? What's happening inside of the SC? What's happening inside of Nix governance from your purview? Tom, you're holding the mic, so you have to start.
Yeah, so I mean, the first order of business clearly was to just kind of, figure out how to work together. That's kind of the first piece because it's a multi-person kind of organization. Then after that, you've got kind of the more top of mind things along the lines of the moderation community teams. We also have issues along the lines of like standing up Nix packages team. And then we have like long-standing concerns, right? So we've got focuses on, for example, we just talked about things along the lines of trademark policy. We're looking at just like how do we improve the health? How do we improve like funding? How do we bring in money? How do we spend money? What do we spend it on? And so like there's like a large breadth of things. I do want to reiterate kind of my call for action from beforehand is that if there's topics that we are not talking about, please let us know. If there's initiatives or things that you care about, you think that would be like worthwhile to have some discussion or impetus behind or some more oomph behind it, then also please let us know. But I'll let, I guess, you guys answer more.
Yeah, so maybe I can say a few words about the moderation team situation because it's a topic that was dear to my heart at the beginning of the term. So the idea was how we recreate some new moderation team and how we make it in a way that is going to be sustainable for the future. And the direction we've been we adopted is to try to involve some of the own moderators that have been in the team over the years and create some kind of team of bootstrap team that of these people that are able to discuss and design with in collaboration with us what is going to be the future of how we do moderation in the community. And so I can say that this has known some slow but steady progress, and we are very close to having this team be announced and start working on that job. Yeah, exactly. Thank you, Philippe.
Yeah, I think the top of mind thing for me, beyond the specifics of the community team formation and the normal cadence of the Nix community, like NixCon, is where can we help say yes to things that are blocked on this indeterminate no that sort of can ambiently hang about the community. I really care about giving permission to activities that the community engages in, and give a clear yes when a clear yes is called for. We saw a few of these things where the formation of the Nix packages core team answered, to my count, about 15 open issues that people had fought about in various PRs. I really like that, and I want to do more of that. So I'm on the lookout for areas that allow us to do more because someone said yes.
Yeah, I think that's a great round of issues from the other three members here. I'm not sure I have much to add on this topic, but yeah, we've I think it's fair to say it was tense times around the last election, but we've been able to get off to a good note and have a good diversity of opinion within the SC, and we're figuring things out.
Sweet. Questions? Wow. All right, let's go.
Yay.
Yeah, so I'll just repeat the general question. It's around, what are we doing about security, state actors, malicious intent? There was some stuff happening at GitHub. Who wants to take that first?
I got an answer. You got an answer?
I got a bit of one.
Wow, that was like, you
Yeah.
just said really yes to that answer.
We have talked a bit about this, both sort of seeing the way the winds are blowing in the world. There's some, and also like in conjunction with binary cache work that was talked about at the State of the Union. So the Infra team did a bunch of good stuff there. That is not only garbage collecting the binary cache, but just like looking what's in it, seeing how it matches the Hydra database. And sort of thinking with, we have that, we have Hydra, and we have GitHub Actions, and we have Aufborg, and what are sort of all the bits of infrastructure we have, and what's self-hosted and what isn't, and what's more load-bearing. So we've begun a bit of audit is maybe a too strong a word, but going on, and we've all seen what's there, and we've also been made aware of some various grant programs around this from usually Europe, and so we're pursuing those two as both like what are our needs, but more likely what are our strengths, and how can we help other people deal with these issues, because we're able to bring so much self-sufficiency that other organizations without Nix would have a hard time getting.
In addition to that, there's a few things that you've probably seen in Nix packages itself. The Nix packages committers repo now has a structured way for people to say yes to new committers, to vet them in public. It's not just one long thread that goes on forever. There's also a standard system for aging people with commit access out if they haven't made use of it. This is primarily to mean that, like, if somebody takes over their account, they no longer have the ability to compromise Nix packages with that commit access. And these initiatives, by and large, are not taken by the steering committee. They're taken by the Nix Packages core team. And so we're starting to see some of the results of the previous SC's, like, for my money, best decision, which is to form a core team that was in charge of Nix packages, and a core team which views this contributor access, contributor health as one of its primary ways of measuring the health of Nix packages, in addition to the security benefits. Do you have anything to add to that?
Agree with all that. I want to add one more thing, which is security is not a like individual sport, right? It's a team sport. So, and it's also not just like, okay, Nix itself, individually, this community alone and unafraid, but it's also us collaborating with and involved with the entire like software ecosystem. And that also means us integrating with them. So that's another piece I'm kind of looking forward to, is how do we integrate like security information? So like things along the lines of like SBOMs and integration with like, security vendors, and how do we make sure that, CVE patching is reported correctly? What are our processes for that? How do we learn about those, and then how do we communicate that we have done those sorts of things? So it's not just like us alone, it's also how do we work with everyone else who's kind of looking at and solving similar problems. So if you also, I'll do my standard refrain. If you have any farther ideas upon this, please talk to us.
Anyone else?
All right, I got another question, unless you get a question in like 3 seconds. All right, what are the biggest gaps right now happening in the Nix community that we could probably take a look at that we're not? What do you guys think? I can kick off, because I'm trying to kind of antagonize the group here. So I've been thinking about this question a lot, right? It's kind of a weird question. Like, what can you do that you're not doing that's really important to do? It's kind of like a mix of a paradigm that you usually don't work against. And I've been thinking a lot about where we have gaps. And I think one of those gaps, if you remember my little triangle from today's session, right, contributors come first, and then you have resources and governance. And resources is a gap. Like, the size of our community, the impact that it has, and the fact that we have about 150K of run rate right now is a joke. Right? If one of our awesome partners decided that they don't want to partner anymore, we'll figure it out. But we are not sustainable for 2 years. And I think it's very easy to point blame at, the companies outside that are relying on Nix. I mean, like, hey, what do you think? Open source is free? It's not free. But I think it also has to do with our ability to show them that there's a path and a way to actually interact with us, contribute, and actually get involved. Now, I'm not saying that no one's at fault here, but I'm also been thinking a lot about what can I do, and what can we do, and what can all of the Nix community do to kind of create more of an industry standard and a path for large and small organizations to get more and more deeply involved, especially when they're more reliant on Nix or have some reliance on Nix. Because the mutual incentives just seem to be there, right? I mean, we have giant companies right now reliant on the binary cache. And the Nix Foundation does not have enough money to run the binary cache for more than 6 months. That is probably not a great situation to be in. Again, luckily we have a partner that helps out with that. But that is not sustainable. So I've been thinking more and more about ways that we can create that standard, create that expectation, and I think it's coming from our ownership to think about it and work it down. Tom's point about if you have ideas, let's think about it, but I've been thinking more about that as we've been going into the grant program, the sponsorship tiers, and I think there's a lot of effort that we need to do from our end, and not just expect money to fall from the sky when we create value. But that's thought I had on this subject.
I have a reaction to that idea. Yeah. One of the things I love the most about the Nix community is our apparent immunity to money. If you're handed money in general, or opportunities of like, say, Azure credits or the like, what reliably happens is that we don't make use of it, and we bumble along, and we make use of our home labs and our desktops and so on and so forth. And the ability to make do with a very little amount of hardware and very little sponsorship relative to the size of our organization. We're in the top 10 by GitHub's metrics on almost every, like on terms of number of contributors, in terms of commit velocity, in terms of health and activity. The only thing we're not in the top 10 with is like the ratio of CI minutes per commits. So we're really big and we're really used by an enormous number of companies, and yet we're incredibly, incredibly frugal for that size. And I actually love that about the Nix community, and I'm a little bit more loath, I think, than you are to change that cultural dynamic, even if it would mean that you would get a lot of benefits. So for me, that doesn't actually fall into the bucket of like, what am I not doing that I should do? Because I know the effect that it has on lifestyle to stop being frugal.
So I agree with you, and I'm happy we're having this discussion, because I think this is the point of like actually an interesting panel and not just us like talking to the either. I think my point here is more about how can we have certainty, right? I think it's less about, oh, let's go.
You want to lower the anxiety factor.
Right. It's more about how can we know that we can sustain this or promise or make a promise to our ecosystem, to our contributors about the fact that we can survive for 2 years, right? Like if all the lights go off, our generator has 2 years of fuel. So it's more about the treasury aspect, and I think what you're bringing up is really important as a cultural standpoint, where if we are, and hopefully we are, able to create these partnerships that are able to generate more resources for the Nix community, how do we make sure that we keep that almost startup frugal mindset, so that can continue on with us, regardless of how the dynamics of the cash flow changes. So I think that's really powerful.
Yeah, I would say kind of in the middle of these two things, definitely we don't want to like increase our OpEx. To me, that's sort of the worst place to not be frugal, but there is some pressing needs on the CapEx side that I don't think making like a few key targeted investments is the same thing as just like the hedonic treadmill of like, well, we're gonna, below our CI is gonna be like very expensive per commit or something. So I definitely think the foundation has a good role to play as like the central thing in the community, sort of neutral party, not beholden to any one company or customer or anything, to coordinate some of the bigger, more abstractly beneficial projects that we can get like a few once and done key wins then that way. And the grant program indeed should help a lot with that.
So, well, I do think we do need to get better at figuring out how to get some resources and spending them and figuring out where is that appropriate and where it's not. I do want to highlight though that is actually a drop in the bucket. Like compare the amounts that we're discussing here and what the budget is, but compare that to essentially all of you. Like you are the most expensive cost. Your time, your energy, just add up your attendance to the conference, and these things start to very quickly dwarf the amounts of money that we're talking about from a foundation level. So part of this is also to make sure that hey, how do we keep encouraging that time, that energy, right? We have a fortunate situation that our community has lots of energy, a lot of incoming interest, right? A lot of communities have that asset available to them. A lot of them are aging out and getting older. They're having problems with, they're having problems, right? And we are in the fortunate situation of lots of excitement, a lot of injection of fresh energy, and we have to kind of cultivate that and mentor it and guide it and steer it and hopefully leverage that to good outcomes.
The question, Tom, was, so what can you do?
Yeah. What are we not doing that would cause that to occur?
Well, I think, what are we not doing? I do think we need the basics covered. So I'm kind of a little bit more around with kind of you on this idea of we should get those basics covered a little bit better so we have more breathing room. I do like that. I do think that we need a way for there to be a venue to have larger scale projects executed in a more reliable fashion. That's, I think, is kind of like the role that, whether that's something that Foundation does, whether that's something done externally, but I do think we need kind of just ways to execute on larger projects. That also involves being able to bring in like more participants, more organizations, and I think that would be helpful. And the last piece is also making sure that we continue to like be welcoming and open to incoming energy. So being able to onboard people, being able to give them like either interesting work, interesting outcomes, being able to hand off like team responsibilities and like develop that new like generation of leaders. All of that like leads to a healthy organization.
Yeah, I want to say that I completely agree with you, Tom, that the resource that has the most value in our community is the people. And for me, one of the big compass of my action in the steering committee is to try to make the community a more healthy place and try to heal existing conflict. We know that there was a lot of conflict within the community in the past few years, and I want to try to create the structure for those conflicts to heal and essentially to happen more difficultly in the future. I don't think we can completely avoid conflict, but we can try to make it less likely that they will happen.
Again, completely agree with everything here. I think that one thing that I feel that we're not doing right now that maybe is not even in our purview or ability to do, but I wish to do it. I wish to say that. Like, is start to create a community that's kind to each other, that treats each other with respect, that uses what I remember from the Ruby community of we're nice because Bats is nice. Like that kind of way of treating each other, even in our diversity, in our differences from each other, is a thing that I have a sincere ambition to do, but I don't know exactly. It's very hard to change culture so that becomes true. I feel myself sort of up against that challenge without knowing how to make forward progress other than being kind in public, being respectful in public, and being truthful and direct in public. And figuring out how to navigate that boundary is something I feel as a leader is part of my job.
Yep, Justin.
Yeah. 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 I've got three things. So to repeat the question, there are young committers, young contributors to Nix packages in particular.
It could also just be newcomers.
It could be
Yeah.
newcomers. Yeah, that's right. Young
We are
in contribution history, who are, because they make normal human mistakes, are ending up either not making those initial contributions or are getting immediate negative feedback as the first thing that happens. And the question is, what can we do to change that culture? So I've seen this culture start to change already. I think there's three things here. The first is there is a very small set of people who believe it to be their job to police Nix packages, and those people have received private feedback that it is not, in fact, their job to do so. that is a key component of maintaining a healthy community, to directly tell a small set of people who have a misapprehension about what good looks like. So that's number one. Number two is that the contributing guides are constantly in the process of getting shortened. I don't know if you've noticed, but contributing.md actually has gotten smaller over time, not larger. And it's gotten migrated to relevant subsections in different files throughout the code base, because you don't have to take on the full complexity all at once. And I think the third and most important from my perspective, because it's technically able, is to move some of those feedback points out of a human being told you to do this and into a machine told you to do this. Because the emotional impact of the machine telling you to do it is just so much less. So that's my three things. I'm interested if anyone else has his thoughts on the matter.
One thing that I want to say, and I think this issue relates also to a much more complicated issue, is that we have 9,000 open pull requests on Nix package, and like it's difficult for some contributors to take the proper time to be pedagogic with newcomers when you have that much pull request to review. So I think one thing that was working a few years back, I don't know if it's still working, was an automatic label on pull request opened by first-time contributors. This helps. That's cool. Okay, so this kind of thing helps to have a special treatment for first-time contributors to help them a bit more than other pull requests. And I think maybe what we need is also try to have some people whose job is specifically to try to steer those newcomers, steer them into like drafting their first pull request in state that is acceptable for the project. I think it can be very hurtful if you try to contribute to the project the first time you get a one-line, two-line review that is like, change this, change that. It can be very hurtful and not human, so maybe we need a special role to make those moments more human. Yeah.
Yes, Jonathan.
I'm also, like, I don't know the stats for that one. What I do know, it may be a good metric. I want to highlight a different metric that's very, very related. So with the advent of the Nix packages committer repository, which tracks both newcomers who are saying, yes, we're going to give you additional rights, additional responsibilities, and additional power, we're also at the same time sunsetting some people's commit access who haven't made use of it and are no longer contributing. I pay really close attention. I'm subscribed to everything that happens in that repository because I want to see more people being said yes to in the future than there are people who've aged out because they stopped contributing. That's my internal health metric that's related to your what's my net customer retention, I think is the stat you're looking at. Yeah. Beyond that though, there's a diversification moment that's happening in Nix right now. Like, I know there's some people who don't like that diversification moment with Lix and determinate Nix and with the way that the community appears to be perhaps fragmenting. I think this is a necessary step as Nix grows. There will be spaces where upstream Nix and upstream Nix packages don't meet your needs, and providing a path where you can be in and out is just absolutely necessary. So I see this kind of moment as being a good thing for our community and something that actually represents people finding a space that's right for them, even though it does come at a complexity cost, where you can no longer make some of the guarantees you could make when there was one unitary implementation, where there was one unitary community. I know that's perhaps my take, not our take, but it is my take. Anyone else?
I do actually agree with that a lot too. I think I wrote something similar in my original candidacy document over a year ago. Yeah, we are always, if you think of like Nix packages as some tightly spinning, wound up thing, as it grows bigger, as it spins faster, it's gonna break apart a little bit. There's gonna be other stuff going on as the community gets bigger, and that is, I think, natural and to be expected. Trying to shove everyone into perfect alignment is just not sustainable and not a hill that anyone should want to die on. So yeah, I'm quite happy to see there's multiple competing things going on. I mean, I just came from the Nix BSD talk my coworkers did, same idea there. Like, it's good to have multiple kernels, not put all your eggs in a Linux basket or a systemd basket or whatever other basket may be. So I do think like the diversity of the members and the diversity of the technical directions both is very important to keep us on a sustainable, resilient path.
Cool. Yeah. So that's actually what's beautiful about Nix. I think what's beautiful about Nix and yeah, sorry. So Jonathan was saying that external communities have found that if there's not an explicit effort, and Jonathan, correct me if there's an addition here, to maintain some sort of alignment between the diverging efforts that sprout out of one community, they become very siloed and almost impossible or very hard to remerge, right? Because at the end of the day, while that's the whole thesis of open source, like you should be empowered to not agree with the current direction, fork it, take it your direction, and maybe it's the better one, maybe it's the better one for everyone, maybe it's the better one for you and your neighbor. I don't know. But ideally, if we're able to merge and reduce the redundancy and reuse, right, core basic parts, we can all kind of like the tide can rise all ships. And like my personal response to that is that I think Nix has a very unique aspect to it that I don't think exists in a lot of other open source projects to a certain extent. And I think that's Nix packages. Yeah. So for me, Nix packages is kind of like the crown jewel. That's where all the data is, right? If we're talking about the AI era, like that's the data layer. And that's where we all converge and all the usage comes into and we all kind of work together there. But then there's different implementations on top of Nix packages that you can use. And I think that's where we're seeing some of that divergence right now, right? There's like Nix, there's Lix, there's a bunch of products and services and stuff like that. But at the end of the day, we're all coming back and contributing down to Nix packages. So I think that's actually a very fascinating, I don't know how intentional it was, you know, at the beginning, but out of the ecosystem and where things are today, it's actually a superpower for Nix as an open source project, and I think why we're able to get so many contributors because of Nix packages.
I couldn't agree more. Like, Nix packages is, there are so many PhD theses which describe a world that could exist, and then 0 people in the world cause that world to exist. There is no necessary through line that means from the existence of Nix the tool to Nix packages, the working repository of basically all open source code in the entire world for as many platforms as anybody can make them work, that has to occur. That occurs because of your contributions, your effort, your collaboration, your passion, and this continued like cycle of building, fixing, maintaining, upgrading, automating, toil reducing, and so on and so forth. I believe that Nix packages is the thing that lets Nix change the world, and I consider it, like Ron, to be the crown jewel. It's the thing that, without which nothing, for me.
All right, we got 10 minutes. So that's about 2 to 3 questions. Yep.
Morgan.
Have we thought about doing like an official NixOS binary capture program where like universities or interested organizations can contribute information to binary
So I'll repeat that. Have we thought about potentially doing a NixOS binary cache mirror?
So there are some instances of this just kind of already happening naturally, but I think you're asking more along the sense of like, how do we explicitly encourage it and set up a...
something like Debian or like various red hat distros like that universities.
Yeah. I know the idea has been discussed before, but I don't think it got like driven to a conclusion. So, but that's something that we could take as something that would reduce risk. It would reduce the kind of reliance upon like existing infrastructure, perhaps reduce costs due to egress. So I see no reason not to. It's a good idea.
Yeah, and I would recommend too, I think Jonas and JFly are around here somewhere, probably just checking with them. I also, with Tom, know for certain that when we had the migration of the S3 cache sponsorship, we had that like 1 week, I don't know if folks remember, it was like, I think 3 years ago now, where like the entire community got together and we're thinking about a bunch of ideas. I know mirroring came up, but I think with Tom here, like I don't think we ever saw it through.
Yeah, really quick, as Tom was saying earlier, get in touch. I think this sounds fantastic to everyone on the panel today, but we don't quite know what partner orgs need for this, especially on a more social than technical level. So please, if you're in this room or you're watching this online and you have some sort of bootleg mirror going, talk to us. We will be thrilled to bless it and make it totally official. That would be a complete win-win. Thanks.
Buddy.
Yeah, the question is, have we been contacted by or in touch with the Sovereign Tech Fund in Germany and other such things in Europe? Yes, we have been. I guess twice now we've applied and gotten a grant from the Sovereign Tech Fund. I am administering the grant from the foundation to the various subcontractees. And there's also the NGI team that has a EU grant, as opposed to a German grant, and we're very aware there's typically the ways things work is less like a dialogue based and more application based, which I have opinions on. But given that's the way it works, we have people that follow this. There's consortium partners on some of the bigger ones. We're definitely very involved in pursuing everything that makes sense.
Cool. Last questions? What's up with the minutes on GitHub?
Thanks, Halen. Halen is asking, what's up with the minutes on GitHub? So, I can, okay.
Yeah, we try to publish those minutes as fast as possible. Some of them in the last months, I guess, are unpublished because they contain a lot of names of people that were in discussion for the Bootstrap team. And we will publish those minutes when the Bootstrap team is announced. So very soon now.
I also have a different answer, which is much more self-directed. I found maintaining the minutes to be a lot of work. and to be able to go through them and to be able to say, is this public, should this be public, should this not be public, it expended my budget for what I can do, and I regret that that is true. Because I have a sincere wish that what we do is public, and yet I know that some portion of that needs to not be public because that's part of what the job is. I know I've fallen down on some where I was the chairperson and just haven't gotten around to, yeah, I need to deal with January. So that's my honest answer.
I think one of the questions here is what can be useful, right? Because the whole idea behind meeting minutes is that we want to make transparent, like things as transparent as possible for the folks that care and want to be involved.
Yeah.
And I think this goes back to the point of like, what does the community want from those meeting minutes or from the aspect that we're currently providing it via meeting minutes? And are meeting minutes still the right format? Does it have to be meeting minutes? Could it be summaries? Could it be, titles? Could it be like, I think there's a potential community discussion about how can we answer the need of keeping transparency that is not causing you guys to have to add 20% to anything that you do because it's about like removing a name or something like that. Right.
Yeah. Yes. Yes, the votes have indeed happened, and that is on us to make that be public. We have like, I have failed my particular campaign pledge of accountability on that respect.
I think that's an exactly improvement point, and I'm happy we're having this discussion because if the community can tell us what matters, at least you guys know that if you got to the P0s and you didn't fill in the 4 pages of like redacted names and meeting notes that maybe no one even reads, then maybe those are not necessarily important. When you have time for that, great. When you don't, at least we know what was voted on and who voted on it, and that's what the community wants, and perfect.
One back there.
Daniel?
So I personally agree with you. I think meeting minutes are, the way we publish them are pretty useless because they require a bit of context to be understood. Like they are the exact word that were pronounced in the meeting, which sometimes is difficult to understand as an outsider. Sorry? Ah, yes. What was the statement? The statement was maybe something interesting could be meeting summaries as well. And I was going to say that I agree with that. Unfortunately, summaries are even like more workload than just the minutes. So ideally, in an ideal world, we are able to sustain this workload, but turns out we are not able to sustain the workload of just publishing the minutes and votes on time right now. So it's 2 steps ahead.
How about this for the things that are outstanding?
I intend to do so when I get
All right, we're gonna have to wrap up. This is, again, super useful, and this was just intended to kick off and re-kick off these conversations recurrently. We don't need to wait for these kinds of panels to bring things up. Write a small note to someone, post it on Discourse, send us some mailing pigeon, I don't know. I had a few other, opening an issue. Talk to Daniel, he knows how to deliver messages via different vehicles. Don't do that. But anyways, this was great. Upcoming next, we have a really cool talk from Ilko on WASM, and I think Burke might be joining him. So we're going to step off. Thank you, guys. Have a good rest of the day. And anyone playing Magic the Gathering, I got some cool stuff that I might be bringing in about like an hour. So just find me. All right. Thank you, guys.
Hello, hello, friends. We have our next session coming up right now. So if you could take your seats, start settling in so we can get started. I think we are all set up and ready to go. So I'm going to hand it over to our next speakers. Please give a warm welcome to both Ilko and Burke, and we're going to be learning about some cool things from them.
You can hear me? Okay, thank you. Okay, welcome. So yeah, this talk is about extending Nix through the power of WebAssembly. So this was a collaborative project between Shopify and Determinate Nix. So the first prototype was built by Surma at Shopify, who unfortunately couldn't be here today. But Burke volunteered to be not Surma.
Instead, we have me, definitely not Surma. You may
Yeah.
remember me from 45 minutes ago.
Yeah, so you're going to explain the motivation for WASM, and then I'll give a bit of a demo.
Yeah.
And, yeah.
So the Nix language, right, is it wasn't designed to be a general purpose programming language, as Ilko can confirm, and yet it gets used as one because it's Turing complete, and therefore, of course, it gets used for everything. But that doesn't mean it's necessarily performant or maintainable or necessarily an enjoyable experience to push into these corners that it wasn't originally designed for. And the first part of this presentation is a bit of a modern history of how Surma came to prototype WebAssembly in Nix. So the motivation was actually, this really ties back to the talk I just gave for those of you that saw it. We needed to package JavaScript dependencies that crossed these inter-zone boundaries in our monorepo. And for that, we needed to do some parsing of lock files at eval time. So if you look at like a package JSON or a cargo toml, this is sort of what we wanted to do, where we have our monorepo zone paths embedded in these files. And so far, this is not a big problem. We could parse this at eval time with from JSON or something. But then when you look at the lock files, these are harder. You have, in the best case, you have YAML. Sometimes you have a totally custom format that you would have to write a parser for. So in the case of a PNPM lock file, which was one of the things we were using, the first step was just import from derivation. We're just going to do this the easy way. We're going to make it work first. We're going to make it fast later. It worked okay. But as predicted, you know, as anyone would predict, this was horrifically slow. We're just instantiating Nix packages, running YQ to convert the YAML to JSON, and then importing it, right? It works, but it's not great. It kind of calls out to be done better. So the first thing Surma thought he would do is, well, I can just write a parser for YAML in pure Nix, because why not? So he actually took, I believe he took the YAML grammar, which is public, and it's 130 productions. Ask me how I remember that number. And he decided that he would just throw Claude at it or whatever and ask it to build a test suite and then grind away at a parser until it worked. And he got pretty close. I think he spent $30 in tokens on it and got to like only 11 failures out of 300. And probably they were 11 that don't matter, like the attribute syntax or back references or whatever. But anyway, the code did not spark joy, so he thought this was probably not the best path to like properly land on. So from there, he kind of started thinking like, what would it take to do this better? So the first thought was, well, it could be a built-in, right? There was some discussion on somewhere in the Nix community about, well, could we have a from YAML? And the thing is, YAML is not a perfectly stable language. It does have revisions that come out. And Nix is unusually sensitive to even subtle variations in these things over time. So it seemed like probably not a great idea. Ilko was even telling me about a problem with toml changing a little bit.
function like this would be very hard to adopt upstream because, well, we had bad experience with from TOML where recently we updated the TOML library and that caused some very subtle behavior changes, I think in timestamp handling. And that's very bad because it means that depending on what version of Nix you use, you get a slightly different evaluation result, and that kind of destroys the whole reproducibility promise. So yeah, that's why upstream we're not very likely to accept more functions like that.
Yeah, and even if we, would have negotiated some way to be like, okay, well, here's our strict subset of YAML, or here's exactly the version of YAML, or something like this, there's no way we're getting from Ruby log file merged into upstream Nix, so that was kind of a non-starter. So from here, Surma thought, well, why not use WebAssembly? He's actually been using WebAssembly since, like, way before it was stable, so this felt like a real cool confluence of things he cares about. So, we're going to have like a little brief detour into what is WebAssembly because it's actually extremely cool technology for any of you that aren't really familiar with it. So the thing that WebAssembly, like a funny thing about WebAssembly is it's not really actually either web or assembly, at least not exclusively. What it is really is a really tiny virtual machine specification that gives you this very simple instruction language and a kind of cool set of sandboxing primitives around it, and it's easily embeddable in a bunch of environments. So to read from the website here, WebAssembly is a binary instruction format for a stack-based virtual machine. It's designed as a portable compilation target for programming languages, enabling deployment on the web and or for client and server applications. So this is kind of what a WebAssembly module looks like when it's running. An important thing about this is that basically a WebAssembly module is a sort of region of instruction code. Optionally, I think, a region of linear memory. So you allocate just a little slice of bytes that the WebAssembly module can manipulate as it runs. And then it's a set of imported function stubs and exported function stubs. Those are both strongly typed. And the only code that a WebAssembly module can call are things that the host provides bound to those imported stubs. And the host can optionally call the exported stubs. So what this means is you get strong sandboxing. You can kind of probably imagine where we're building towards here. This is kind of convenient for a sandboxed execution mode. An interesting thing is you could have kind of state leakage across time. If you would instantiate the module once, this linear memory would provide a vector for statefulness. So you just have to also make sure that you don't allow linear memory to persist across invocations, and then you have referential transparency and statelessness. So this is the way that we can use WebAssembly modules to provide something that sort of lends itself well to a Nix evaluation time context. So, okay, we can look at WebAssembly and say this would be great if we could use it. How do we use it, right? So WebAssembly is WebAssembly. It was meant to run non-JavaScript code in browsers. But because it's such an appealing little virtual machine and a fairly simple specification, people have written all kinds of implementations for it. So basically you name a language ecosystem, somebody has written a WebAssembly compiler, interpreter, JIT compiler, something. And it's now available in anything, and plenty available in C and C++. It's actually a fun project to write a WebAssembly interpreter if anybody feels like they would like to get nerd sniped for a couple weeks. So the first thing that WebAssembly actually kind of grew out of an earlier project called ASM.js. And what ASM.js was this idea of, man, JavaScript is slow, right? What if we could compile C to JavaScript, a restricted subset of JavaScript, and then have browsers optimize specifically that restricted subset to kind of provide a path to almost have the JavaScript be a facade where you're actually scripting a virtual machine, but it still looks like JavaScript and ships like JavaScript so that browsers that haven't implemented this feature can still run it. So the first compiler written for to target this feature was called mscriptin. and it compiled C and C++ to this JavaScript subset. And actually, these days, with WebAssembly, mscripten still is sort of like the premier compiler, or at least one of the most well-known ones, that compiles C and C++ to WebAssembly. So this is still a perfectly valid choice. But nowadays, there's also a bunch of Rust actually very competently targets WebAssembly. There's more recent compilers for JavaScript, Kotlin, C#, a bunch of other languages. So these days, you can pretty much compile anything, with some asterisks maybe, to WebAssembly. And you can pretty much embed WebAssembly in anything. So it makes it really excellent as a plugin system because it's actually kind of an anything-to-anything plugin language with strong sandboxing guarantees. And that makes it pretty interesting as a what if we could put it in Nix thing. So the thought here then was, given all that, what if we take this Rust YAML crate, compile it with some minimal wrapper to WebAssembly, and then somehow plug that into Nix so that evaluation time code can just call this YAML crate to parse the YAML, yield probably a JSON object back, and then be off to the races without any of this hundreds of lines of some of the ugliest Nix code you've ever seen to parse YAML. And that was the genesis of built-ins.wasm. So Surma wrote a prototype that the presenter notes here say was terrible. I won't comment on whether or not that is true. But certainly Elko's version turned out much more shippable.
Thank you. So those were Surma's own words, and not mine. Yeah. So what we did was, so the initial Surma's version was basically a JSON to JSON transformation. So had the C++ side would had transform a Nix value into JSON, then call some WebAssembly on that, and get a JSON string out, parse that, and you'll be on your way. But that's kind of inefficient. You can't pass, say, large values like Nix packages or a NixOS system configuration and do stuff with it. So we want a more efficient interface. So here's an example of what it looks like to do something like writing a Nix function, in this case in Rust, that calculates the end Fibonacci number. So this isn't super exciting, but what all of these functions look like is they transform a value into a value. So this thing, capital letter V value, that type represents a opaque value on the Nix heap, and that can be a lazy value. So it might be unevaluated, but we don't care about that. So it takes one value, which could be, say, an attr set or a list or something arbitrarily big, and it's supposed to produce another value. So what it does, in this case, this value is supposed to be an integer, so we call getInt on it, and this is a little Rust helper function that calls a wasm host function, so that causes the wasm runtime to suspend wasm execution and call the Nix C++ side to check what this value actually is, check that it's an integer, and if so, return the actual value of the integer. Then we do the Fibonacci calculation as normal, and then we call another host function to produce a new value on the C++ Nix heap. So this is how you call it. You just say build-ins.wasm. You pass it the path to your little wasm file compiled in or compiled from whatever language you're using. You tell it the entry point, in this case Fibonacci, and you give it the argument. So let's just prove that that works. Well, actually, let's first compare it to a native Nix Fibonacci. So let's take, a number that is not too high, because otherwise it will not finish in time for this demo. So this is the native Fibonacci. Okay. And here is the Rust WASM version. There we go. It's a lot faster. So that's amazing. Here's another cool example. We have Mandelbrot. This is, of course, what everybody needs in Nix. Oh, this is not very helpful. Let's do raw output. There we go. Beautiful. Okay, yeah, I mean, I already mentioned the performance, but yeah, this can be orders of magnitude faster. And very important, use much less memory. So Fibonacci 40 takes 4.5 gigabytes with the native Nix version, because it's this purely functional thing that's constantly allocating values and then not freeing them until your memory gets full, and then it triggers a garbage collect. And the WASM implementation doesn't do any of that.
So it's a little bit faster.
It's a little bit faster, yeah. Yeah. All right. So, but one important thing, so Burke already mentioned this, but we of course, we want an extension mechanism that ensures the purity of the Nix language. So we don't want to enable people to write impure functions in WebAssembly. Rust, of course, is a imperative impure language. So here we have a function counter that increments some global static variable every time you call it and returns the new value. And that would be very bad if you could actually do this in Nix. But with WebAssembly, every time you call this function, you get a fresh instance of the WebAssembly memory. So to see this, so here we have this counter function. We call it, and yeah, as you can see, every time it's reset to its original state, which makes it a little bit less efficient. It would be nice if we could reuse these WebAssembly instances across calls. But the runtime that we use, WASM time, has this pre-instantiation feature where it will create a sort of an instance, and then it will do this copy on write optimization. So it's pretty fast. You can do something like on this laptop 125,000 WASM calls per second, which is a lot less than the number of Nix calls that you can do. So typically you want to use WASM for sort of bigger tasks like from TOML. Or from YAML, which was our original use case. So that, of course, now also works. For example, here we have a little YAML file. And now we can say from YAML, and there we go, that works. And we can do to YAML. Yeah, beautiful. And the implementation of this, I can probably show that. Yeah, here we go. I mean, is pretty short. Basically this is, I won't go to the details, but the important thing is Rust has a YAML crate. So all we have to do is hook that up with Nix values and convert between them. But all the real work is already done. All right, so that's awesome. A very cool demo that Surma made is executing JavaScript in Nix. So there is this quick.js crate for Rust that allows you to evaluate JavaScript. So he just hooked that up. So let's see that. So we have this little JavaScript program. So now I'm going to do JS eval, JS test, and there we go. It's done. So yeah, now you can, in addition to writing your functions in WebAssembly, you can also just write them in JavaScript and completely dynamically interpret it. So yeah, that's another thing you can do now. Another cool thing, so this morning we had a great talk about Nix native by Tom, about using Nix as a sort of a native build tool. So a build system has essentially a replacement for stuff like Make or CMake or Ninja. And there the challenge is that you need to discover, if you're building something like a C++ project, for every compilation unit, so for every top-level C or C++ file, you need to figure out all the transitive header file dependencies, because we want to make every compilation unit its own derivation, so we can get nice incremental builds. But yeah, we need to figure out these dependencies. So in that talk, they used dynamic derivations for that. So here we're using builtins.wasm for that, which has one very nice property, which is that it's not a derivation, so it doesn't require copying your source tree to the Nix store, which for something like a multi-gigabyte monorepo is very important. So yeah, let's just see that in action. So I'm actually doing that. I applied that to a bit of Nix itself. So I'm building a libutil, and yeah, that worked because I already compiled this. But now let's modify a file, and now I rebuild, and voila, that's done. And so so to show what's happening here, so we have this WebAssembly function, get dependencies, that takes a source tree. So I'll do that. And this is pretty fast. So this is something like 400 source files. But parsing all those source files and all the header dependencies transitively, yeah, that takes something like 0.1 seconds. So it's pretty fast. And that tells you for every source file what its dependencies are. And a very nice feature here is that it also tells you at the granularity of individual source files what the system dependencies are. So for example, we have this one source file, computelevels.cc, which includes libcpuid, but nothing else in Nix includes the headers of that package. So now let's simulate that we update Nix packages, and the only thing that we change is that we update the libcpuid dependency. So we're going to change something here. And now I'm going to rebuild. Yeah, and now it knows that it only needs to compile computelevels.cc and nothing else. And yeah, and here is our library. So yeah, that's yeah, this is very nice, I think. Okay. How are we doing with time? Are we okay? Okay, great. So now something completely different. So everything that we had before was about using WebAssembly to extend the Nix language, so to use it at evaluation time. But now that we're linking against this WASM runtime, we may as well use it for other things. And it turned out to be something like 5 minutes of work to add platform-independent derivations. So what you can now do is have derivations where you set system to wasm32 wazi p1, and you give it a wasm file as the builder, and yeah, that will be executed by the wasm time runtime, and yeah, so you can have derivations that work on any platform. Now, where is that useful? For example, in things like the Nix packages bootstrap, where at the start of the process, before you start, compiling the C compiler, well, you need stuff like a shell, or maybe you need curl to download things. And yeah, where do you get those from? Well, what Nix packages does is have a tarball with statically linked precompiled versions of those things for every platform that Nix packages supports. So if your particular platform is not there, then you cannot use Nix packages there until you figure out how to do how to generate those bootstrap binaries. But maybe in the future we could just have a bunch of WebAssembly binaries at the start of the bootstrap process, and yeah, solve that problem. And also, you could imagine stuff like fetchers. So something like a curl download function that could also be done in WebAssembly. So yeah, there are probably lots of other applications. I mean, WebAssembly is just a great mechanism for a plug-in system. So the status, so this is currently an experimental feature in Determinate Nix. We shipped that last week. There's also an upstream PR if you want to play with that. And we just published a blog post that has all the links to all these things if you want to check it out. And yeah, so we're very interested in your feedback if you want to, yeah, for instance, try out writing WebAssembly or Nix functions in other languages than Rust, because we've really only done Rust. So for instance, one thing that we need to figure out is whether our host interface is sufficient for yeah, all the use cases that that people might have. So yeah, we're really looking forward to your feedback. And I think that's about it. Do you have anything else to say?
Nothing to add.
All right, then. Thank you.
Thank you so much for giving your session. Will you be around still if people have questions for you?
Absolutely.
Outside?
Yep.
Yeah, perfect. Or, yeah. All right, how's everyone feeling? Yeah, we're almost at the end of Planet Nix. We've got one session left. Yeah, I know. I'm like, where did the time go? I can't believe we're already at the end. Is everyone having fun? Learning lots? Yeah, thank you. While we're here, just in case you didn't know, we do have an after party coming up, so feel free to sign up for it. And we're just getting set up for the last session. Michael Stanke is going to be talking about AI. I know there's more to it than that, but yeah. No, it's at Rocco's, yeah. Yep, 3:45. So we're just getting set up to get started, so if you could settle in, get ready for the final talk of the day, and then we get to celebrate a completed Planet Nix together. No problem. Huh? Everything's fine. Everything's awesome. Is there anyone here who it's their first Planet Nix? Just out of curiosity? Well, yeah, lots of people. Cool. How about second Planet Nix? Yeah, nice. Me too. Second Planet Nix over here. Very fun. Yeah, we doing this. All right. So if everyone could give a warm welcome to Michael Stanke, our next speaker and our final speaker.
Howdy, y'all. We apparently ordered ice cream, so there's ice cream in the back. And I won't even be mad if you go stand up and get some. So, because I already had some and it was delicious. All right. So, we're going to talk about Nix and AI. And these are topics that have probably been basically plumbed throughout the entire week, regardless of what you were doing. So, but I want to talk about it from a user perspective and that kind of stuff. So, that is way more than one slide at a time. All right, we're going to do it this way. So basically, AI has every problem that Nix was built for, and this is really fascinating because our AI has all these weird things going on. We have all these LLMs and all this stuff, and we have to figure out what we're going to do with this. So we have dependency chaos. We have a lack of reproducibility in the AI world. In fact, we call that a feature in the AI world. We don't have reproducibility. We have non-deterministic systems now. And that's fascinating, but we still have these problems of how do we run these different models, how do we do training, how do we do inference, all these types of things. And then we have these huge artifacts and these complex setups. And Nix was really designed so that you could get reproducible setups, and that if there was something that was super complex, you could solve it once and have it work in multiple positions, multiple outcomes, multiple platforms, multiple targets. And that's exactly what we want from our AI stacks. So I'm going to be talking about this from a couple different perspectives. In one of these, I will be an ML engineer, and that is when I'm wearing this hat. And in others, I will be me, who's more of a classic release engineer kind of person. And in that, I will not be wearing a hat. So did I add props for this talk? You're darn right I did. So I'm Mike Stonke, like I said earlier. I run engineering and marketing at Phlox, and so I do some different stuff. I've been doing more marketing lately, and that's been interesting, but here we are. And over the years, I have been a maintainer of Fedora. I was one of the people that founded Apple. I was a maintainer of Debian. Like, I've done all sorts of packaging. I ported Ruby to AIX. So, you know, I've done stupid stuff. And Nix is something that I only got into a few years ago when I started working at Phlox. I was aware of its existence. I wasn't that interested in it. Now I'm sad that I didn't learn it a lot earlier, but you know, we live and learn. So my main question was, why aren't these ML teams running Nix? Because everybody that I talk to that is doing ML, nearly nobody is running Nix right now. And basically what it comes down to is, okay, so I read this tutorial, and it said I'm supposed to use Conda. Okay, so I'm going to go grab Conda, and I'm going to go play with this. And then I figured out how to do something, and then it said I needed to do all this stuff using pip. And then it said that I need to build everything from source because there's no other way to guarantee how all this stuff works. But I'm a data engineer, and I don't know how to build anything, so that's kind of not going to work super well for me. And then it says that on Linux, I need to do it this way, but on Windows, I need to do it this way. But I'm on WSL, so I don't even know which ones of those actually apply to me right now. And you just get really, really confused. I have teammates that can train models, and their setup doesn't look anything like my setup. And you know what we do? We don't talk about it, because it's just scary. I can't figure out what they're doing. They can't figure out what I'm doing. We just have to recite the incantations from the great old ones, and then things will happen. So both of these work. Me, my colleagues, we have handcrafted these systems. We have artifacts that are left over from failed Conda installations, virtual environments that are not active, but maybe they're still in the path somehow. We have all of this stuff. But it works, so I don't touch it, because I'm a data engineer, and being a system administrator was not my goal in life. And as a data engineer, I'd like to point out that I've done a lot of really smart things in my life. So I'm not a dumbass who doesn't understand how to do stuff. It's that I have different incentives than what a lot of people do that are very pro Nix. It's not really a skill issue. Like, a lot of these people have PhDs. You know, they're very, very smart people doing all these ML researches. And so they just go find a tutorial on the internet. I go find a tutorial. My colleague finds a tutorial. Is it the right one? We don't know. We just keep trying stuff until it works. I got it working. I'm not touching it. I'm going to leave it alone. When you think about it, that's pretty rational behavior. You've done a bunch of complicated stuff. You finally got something to work. You're not really sure why it worked or how it worked, but you did it. And your job isn't to have a reproducible system. Your job is to train a model. Okay? And so every part of the SDLC that has a handoff becomes infinitely more complex because I don't know how it got there. Somebody has handcrafted this thing on their laptop. They've done Python things that are unholy, which, in my opinion, all Python is unholy, but that's a totally different issue. And so they've done all this stuff. And what happens then? Somebody in some operational capacity, usually, it could be a DevOps team, could be classic ops, could be infrastructure, whomever, says, all right, it's my job to reverse engineer the incantations that this data engineer has taken so that we can put this into something that resembles production. Maybe it's a staging fleet, maybe it's a production fleet, whatever it is, I have to do this. How many people have reverse engineered a data engineer's stack and tried to figure out what the heck they did? Yeah, I mean, I have, and it's super fun. And so basically, if you have 2 different data scientists, you have 2 stacks to start with. If you have 3 data scientists, you might have 9 stacks by then. Somehow they multiply. It's a weird math, but it works out. Trust me, I've seen it in real life. And so this conveyor belt of how you do things across the SDLC ends up being built out of duct tape, where you find a solution and you tape it on. You find another solution and you add it in. And so maybe it's a bunch of if statements, maybe it's a shell script that does checking, whatever it is. It's all these different things. But this is where Nix should shine. I need reproducibility. I need a thing that works on one platform or another, one target or another. I don't want to have giant models in everybody's home directory. I'd rather have them in a store path where if they're referenced again, I don't have to install them again. There's all sorts of great things here that we could be doing with Nix. And so you tell your data team to use Nix, and your data engineer says, do you hate me? Did you just tell me? No, we're not going to go down that. So where do I start? Where do I start if I'm a data engineer? I'm supposed to use Nix. All right. I'm pretty smart. I'm a data engineer. I probably have a PhD or something. And they're like, well, first you start with this thing called a derivation. And you're like, cool. I'm going to go back to my abstract math theory classes and go figure out what that means in this case. And you just start hearing other words, store path, derivation, like all these things that seem pretty foreign to somebody that spent their career training models, perhaps writing some Python, mostly doing math. It's a little weird. Do I want to use Nix develop or Nix shell, or I'm supposed to do something so that I can see the header files, but I don't know where the header files are, but I need to be able to link against them or compile or something. And so there's just this complex entry point. The shell and the path feel very unfamiliar. And the way that happens and how this exposes is they go to read a tutorial on the internet, and the internet tells them, you know, you're going to type user bin pip or whatever, and that's not where pip is when you're using Nix. And so you're very confused already. And so a lot of people, they get to a certain point and they just jump off because they're like, I don't know how to apply this into my life. I'm sure this is brilliant, but my job is not to sit here and reverse engineer the way this works. Just like you didn't want to reverse engineer the data stack, the data engineer doesn't want to reverse engineer your Nix. So it's a bidirectional problem in some cases. And these tutorials fail in all these subtle ways because of these hard-coded paths or these assumptions that when you're on Windows it looks like this, or when you're on Ubuntu it looks like this, or they assume that when you say you're on Linux they always assume it's Ubuntu for whatever reason. And that's the way that all these tutorials work. And so the cost of this is that feedback loop is really expensive. You're trying to cycle, you're trying to iterate. All you wanted to do was run a bunch of inference on a model and then run evals and test it and see was it, you know, within bounds or not. And instead, you're spending all this time on infra. And so then, let's say they get that far. I get a data scientist. They get into Nix. They actually think it's cool. They're using it. And then they want to go use some Python thing that isn't in Nix packages, or that's outdated in Nix packages. And that happens, we'll call it 100% of the time. And so now they have to go figure out how to either get something into Nix packages or use the Python things that they need without Nix. And then they get into a religious discussion about purity with their systems team, which again, wasn't their goal. Their goal is to try and train a model and figure out if the model's good or not. That's the entire workload. And so so these broken guarantees debates, all those types of things with impurity. Like, do they just run pip? What do they do? And so they also need to set up builders and substitutors or whatever if they're going to start building their own packages. And then they eventually realize they become a release engineer and not a data engineer, and now they're mad at you again. So this is why when they say just use Nix, the data teams often don't succeed or don't choose to do that. And their barrier, again, is not intelligence. It's the workflows. It's the ergonomics. And it doesn't mean that Nix is terrible. I'm just trying to look at this from another perspective of you want me to change the way I work so that we have this reproducibility, but this tax is pretty high in the cost of my workload. So there is some good news about some of this stuff. I don't know if you've ever tried to use CUDA with Nix. It's super fun. Phlox and the NixOS Foundation and NVIDIA are working on making that way more available. It was in a private kind of GA thing for a little bit. It'll be a little better. But we're still working on it because we know that we haven't solved every use case. We haven't solved every edge case. We haven't solved much of the availability of it depending on what commit you're on in Nix packages and stuff like that. So still coming. But at least there's a dialogue going. It started with a bunch of legal documents, and now we're actually working on the tech part of it, and that's more fun. So, yeah, I just talked about that. But it does prove that some of these barriers can move, because I think CUDA being difficult to redistribute, difficult to get going, was a long-time problem on basically every Linux distribution. It wasn't related just to Nix, but Nix made it also difficult. And that's getting a lot better. NVIDIA's been kind of seeing the power of their reach and wanting to have CUDA succeed more, and that's awesome. One of the things that you want for this reproducibility is that oftentimes training ends up on GPUs, but production inference actually happens on CPUs, which blew my mind when I learned this because I thought everything ran on GPUs all the time now, but apparently they don't do that all the time. They run a lot of things on, once they have the model all trained, they can actually kind of shrink it, optimize it, get it on CPUs, run it cheaper, I guess. I don't understand that exactly. But you still need reproducibility of here's how I do the training and here's how I do the production deployment. And now you want both of those to be analogous appropriately. So the environmental strategy needs to cover reproducibility for the data engineer, handoffs across the SDLC for the platform type engineer. It needs to cover reproducibility for GPUs or for other targets that are CPUs. So there's just all sorts of stuff there that is not straightforward from a user perspective. And so I have some recommendations on how to handle this. And some of these, I would bet this room doesn't like that much. And I'm going to be okay with that because I say stuff people don't like all the time, so I'm pretty used to it. One is, there's this seam. And you can use Nix and have a lot of power, but inevitably you will run into Python packages that are not available that you wish were. And so the way that I've solved this with people actually doing this work is saying, if it has a C extension, get it from Nix. If it's pure Python, get it from PyPy. It mostly works. The last thing I want to do is download giant wheels. I think wheels are an abomination of a packaging format. I don't know how else to put it. It makes me very sad. So basically, it's not Nixify everything. Don't do everything with Nix, because I think that that is chasing your tail. Like, I just think it's an exercise in futility. I can't mirror all of PyPy and get it into Nix instantly per commit, per change. It's not just use Docker, because that isn't going to get me the Python packages. Like, it just doesn't solve that problem. It just shifts it, the shape. It puts it in a different shoebox. So basically, try and have your own system. Have CUDA, PyTorch, binaries, C extensions, all that kind of stuff. And then start, so basically you own the system native dependencies. And one thing I really like about this is that at least in a Nix shell or in a Flake or in a Phlox environment or however you do this, you have your dependencies that are explicit instead of implicit. Because with Python, usually what happens when you try to install something, if it's not a wheel and it needs to link against a library, the way you find out that you needed that library was it fails to install and you read an error message, because there's no way to say, I depend on libxml2 or whatever it is that it depends on. And it's the same problem with JavaScript or Ruby or whatever else. Like, that's all there. And so what I've been recommending is UV a lot. Again, I'm not a super big fan of the Python ecosystem overall, but UV seems to be the least worst of all of the Python package managers, and there are only like 28 of them. So, but UV is the one that at least translates into Nix, I think probably the best currently. Poetry is decent, but UV is a little better. And so using UV to Nix, you can actually get more purity there if you have the same set of dependencies that you keep using over and over again, and you don't need to go augment with a different set every day from a different data engineer. So I try and have UV own the pure Python dependencies and try and have Nix own the stack that is native. And then I get some provenance in there because I have the native stack. If I can trace this with UV to Nix, then I get the provenance of the rest of the items after a trust on first use setup. Which, again, trust on first use has its own set of problems. Not going to get into that one right now. And then I have a practical workflow that I can hand to a data engineer and say, okay, I'm going to give you a dev shell. And it's got all the C extensions you need. It's got Python at the version that we want you to use. It's got the drivers for the GPUs or whatever. And from here, you can type UV and get what you need. That was the goal. And that has worked. Now, the other thing is, because I can get the exact things that I want, I can start to optimize this. Instead of getting this 800 megabyte wheel that has PyTorch in it, I can just go build Torch for the actual GPU that I want and package that up for my consumers. And now I've saved 75, 90% of the disk space that I was going to use otherwise. I find that to be really nice. Some people don't care, but it all depends. Are you out of disk space? Or do you spend a lot on network transfer? Is it just waiting time of things transferring back and forth? It's also faster. Thanks, Tom. And so these AI and ML packages need to stay fresh continuously. This is a priority. If I was going to make a recommendation to the Nix community, it would be how do we keep these Python packages more up to date? And that includes the rest of the AI stack as well. It's difficult to do. Some of this stuff moves super quickly, and I'm super happy when I watch Nix packages flow. Others of it, you might as well be singing happy birthday to the last time it was touched. And it just depends on what package it is. So I guess I would say that I would love to see the community adopt a way to push the envelope on Python specifically because of this ML side of things. Yeah, the freshness is highly variable, as I said. So the better thing is, and the other things are, UV to Nix, I've had relatively good success with UV to Nix. Dream to Nix, I've had maybe less good, but I like the idea of it so much. And right now, most of the time those work, but they can still be a little better. I think they've been kind of in the same state for the last couple of years in my experience, but maybe they've gotten better. I don't use them every day, like I'm not in and out of them all the time, so if I'm wrong on that, I'm sad. And then the final thing is to be friendlier with your ML teams and actually have some empathy and be like, I understand the data you're trying to do or the workloads you're trying to run. I understand the models you're trying to train. I understand what you're measured on. You're not measured on reproducibility. Like, no boss is going to reward that data engineer for having a reproducible environment. It's going to be the model has a success rate of, above a threshold of some kind. And so as an infrastructure person or as a platform engineer, I have to understand that those incentives are different than mine. But my incentive is to make their work as efficient and effective as possible. And so I'm going to help them with that stack. And so you can reduce the shell friction, whether, again, giving them a flake, a dev shell, an environment, whatever you need to do. Give them tools that are handcrafted for them, that are reproducible, that are used, but you've built them for them, understanding their workload. Build some paved roads and really work on improving the UX. Document things. Maybe make your own GPT for it. You can do all sorts of things that can help people. But I find that there's a big barrier between this ML data teams and these platform infrastructure teams right now. They don't talk. They don't see each other as human. They call each other idiots. You don't understand what I'm trying to accomplish. It reminds me a lot of this like dev and ops thing that we used to talk about for a long time. I don't know, it rhymes. And so one thing that I was going to bring up earlier originally, and then I moved it to the end, why that's important, don't know, is that AI actually could help us here. And that's, so 2.5 years ago, I didn't know how to write a Nix expression at all. None. Every time I looked at Nix, I questioned so many things about my life. And I just chose ChatGPT. I had a Go project, and I said, hey, build me a Nix expression to package this up. And ChatGPT said, sure, I'll go do that. And then it didn't work. And it said, you're absolutely right, it doesn't work. And I kept working on it. And it took 31 iterations of me going back and forth with ChatGPT to get an idiomatic, very simple Go project packaged. And I was like, well, I don't have to worry about this taking my job anytime soon. I did this yesterday. Same package or same Go project. I mean, it's been updated a little bit, but basically the same layout or whatever. And I gave it one prompt and I said, make this a Nix package. That was it. That was the entire prompt. It built the first time, no notes, absolutely worked. It was fine. Was the Nix expression exactly the way that somebody probably wanted to see it? It was pretty darn close, honestly. It was super good. And so from that perspective, maybe the gap between data engineers and platform engineers doesn't need to be as wide because there's a lot of learning that can kind of be absorbed by other AI tools, or you can help and say, hey, these are the types of prompts that would work really well for the work you're doing, or I can give you a prompt, or I can actually just build a machine that you submit your code and we just spits out the other side a Nix package and you don't even need to know how it works because I'm doing inference on my end. That's great. And so I'm going to summarize this and let you all go back to ice cream and go to happy hours or whatever it is you all want to do, talk Nix all night. Getting weird. But basically, if we can keep the Python ecosystem and the AI ecosystem as fresh as we can in Nix packages, it's going to lower the friction between data engineers and platform. If we can improve Python getting into Nix through things like UV to Nix or Dream to Nix or other to Nix type activities, that also can make things a lot easier. And if you, as a platform type engineer, which is just a proxy for whatever that role is that's doing those things, can have a little bit of empathy for the way that the data team works, understand their incentives, and meet your users where they are, think like a product person, understand your users have needs, and deliver them the things they need to do their job, I think we can actually make a lot of headway here, and I'm really excited about the space. So are we there yet? No, we're not. There's still a lot of gaps to fill. But the shape of this answer is starting to become more clear to me, and that it's that the gap is closing kind of from both directions, where the data scientist is getting a little more familiar with needing reproducibility, the platform engineer is getting a little more familiar with data science because of all the AI stuff that we're all playing with and touching all the time, and these LLMs are actually helping us bridge the gap between the two really, really nicely, because now they can actually write decent Nix, at least for some things. I haven't tried super complicated stuff because I wouldn't know if it was right, I'll be honest. Like, I have not tried to package something like KDE, you know, so that would be rough, I assume. If you want to see this talk, that's where it is. The slides are up. Otherwise, I'm Mike Stanke. Thank you very much for coming to Planet Nix. And thank your sponsors as well, again. And cheers. Have a great evening, y'all.